Hi there, and welcome to my course, SQL for Newcomers. I'm Sameh Sharaf. I'm a data engineer and have been working with relational databases since 2010. In this course, you will learn how to use SQL. Whether you are a student or an employee who needs to work with databases and need to learn SQL and add it to their resume, this course is definitely for you. SQL is a standard language which is essential to work with all popular free and commercial relational databases. If you learn SQL, you're able to use any of those products you see here. This course will use PostgreSQL. Why? Because it's open source, so it's free. It proved to have the best quality performance comparing to other open source relational databases available, and it has good documentation with great explanation for each keyword and function in SQL. If you need to learn more by yourself after this course, it will be quite useful. Okay, without further ado, let's start and hope you enjoy the journey. Happy learning! Okay, let's start by getting and installing the needed applications to begin this course. What are we going to do is, we're going to install a relational database manager or an RDMS like PostgreSQL. Why using PostgreSQL? Well, it's because it's open source, so it's free of charge. It proved its performance and quality comparing to both free and commercial RDMS systems that we have today. And it has a better documentation in case if you need any help, you can simply look into the internet. And there is documentation on its website. Next, we're going to use a SQL editor in order to connect, run, and execute our SQL scripts. What we are using is SQL Electron. It proved to be good, it's free, it's open source, it's light, and it has many features that we can use in this course. So let's start together and download and install those two applications. Let's start by downloading PostgreSQL. From Google, I'm going to type PostgreSQL. Here you go. I'm going to check downloads, and from here you can see that PostgreSQL supports multiple operating systems, including Linux, Mac, and Windows. Since I'm using Windows, I'm going to check Windows tab, and from this page you can see what PostgreSQL version is available at the time of this video. It was 10. And as you can see, for version 10, it supports the following 64-bit and 32-bit for those platforms. In case you don't know which Windows version you are using, you can go to the top of the desktop from My Computer or this PC icon. You can choose Properties. From here, you can see what system type do I have. So, you choose which version of Windows you need to install and download. For me, I have 64-bit operating system, so I'm going to choose this the next time I'm trying to download PostgreSQL. I'm going to download the installer now. And it will direct me to a new page, which is the EDB PostgreSQL project. From here, I will choose enterprisedb.com, which we can download PostgreSQL, and I'm going to choose my version, which is 10.1 for this course, and my operating system as Windows 64-bit. Click Download now. Okay, my download is ready, and here is a double click. Next, I will download it into the default directory. I'm going to keep it at, and next. Here's the directory where your data will be stored. In case if you uninstalled PostgreSQL in the future, you'll still find your data here to be restored later on. I'll keep the same folder. And here is going to ask us for the super user we're going to use in PostgreSQL. Since we are doing all tasks on our local machine, we can choose any password that we want. Later on, you should consider a very powerful password for yourself when you need to launch any database in the future. This is my password. I type it again. Then next. Here comes the port, 5432. Remember this because we need it later. I'll keep the default one and press next. Here's the locale. If you're using any language other than English, you can use it as your default language for your database. I will keep it the default. And I'll click next. Another next. And here we go. It's going to take some time, so be patient and I may speed up the video. My installation is done. Before that, I'm going to uncheck the Stack Builder option from here since we don't need to open it. I'm going to finish the installation. Here we go. We're all done with installing the database. What we need to do next is installing a SQL editor, which we need to connect to our database and run our SQL scripts. Now let's start with installing the SQL client that we can use to connect to PostgreSQL and run our scripts. From here, I'm going to type SQL Ictron. It is the editor that we're going to use. From the first link here, we will choose SQL Ictron and we're going to download the GUI version since we're going to use it on Windows instead of the terminal. SQL Ictron is an open source and free tool to use and it's available for Linux, Mac and Windows. I'm going to download the GUI and here it will show me the latest version. By the release of this video, I have 1.28. You can find this version based on the time that you are downloading and installing the SQL Ictron. From here, you can see multiple links for downloads based on your operating system. For Windows, you need to choose the exe file. For Mac, you need to use the DMG, and for Linux, if you're using Debian, it's DEB, and for Ubuntu, it's RPM. There is also the compressed files as well as the source code. We're going for exe, and I will select it and download it. After downloading the installer, I'm going to launch it and waiting for it to be finished. And it's done already, and we're going to see the logo. Nice. Alright, we installed SQL Ictron for now. Let's see how can we connect to the database. In order to connect to PostgreSQL, we need the following information. First, you need the database user. We're going to use the admin user or super user called Postgres. This is the user which you define the password when you install PostgreSQL. Next, you need the database that you will connect to. PostgreSQL allows you to create multiple databases based on your needs. The default database we will be using is also called Postgres. Sounds easy for now. Next, the host. The host is the server which PostgreSQL is installed into. Since we installed PostgreSQL on our local machine, the server will be the local machine, which is localhost or the IP 127.0.0.1. Since localhost is easier for us to use, we're sticking to it. Next, the port, which we defined when we installed PostgreSQL. If you kept the default port, it will be 5432. If you change the port, you can use that as well. Let's see how can we put that in SQL Electron. Back to SQL Electron. Let's connect to PostgreSQL. From the Add button here, I'm going to click it. And from the information, for the name of connection, you can name it SQL course, or any name that you like. From the database type, we're going to choose PostgreSQL. And from the server address, which is the host, we're going to call it localhost. The port will be 5432. In case you change it, you can get your own. For the user, we're going to use the super user, which is Postgres, and the password you added when you installed PostgreSQL. Finally, the initial database or key space, which is the database that PostgreSQL created for us, which is Postgres. To test our information, we can click Test and see if it works. And here you go. Connections tested and successfully connected. Click Save, and here we have our connection ready for us. Click Connect, and you are all good. If you see this, then congrats, you're connected to PostgreSQL. Your machine is all ready, and we can start the course. Okay, after we prepared our database and we installed PostgreSQL on our machine, we need some data to experience on and learn in this course. I've generated some random data to use it in this course. You can download it from the attachment in this video. You can find an SQL file. And after that, I'm going to show you how to import the data into your database. Let's start by opening SQL Electron. Next, connect to your database. Alright. From here we can go to File and up to Open Query. From here I'm going to open the file that I downloaded. Here we go. Here are the file, and those are the scripts that we're going to build our database, our tables, and the data that we're going to use in this course. Don't be scared if you don't understand what is that. We will learn all this eventually. What are you going to do now is you can simply click Execute. Here you go. When it says query run successfully, all those means that every query or every script is written here has been run and done successfully, and seems everything is working and all is good. But you can notice it's when you go from here and you click on the right click on your button on Postgres and refresh the database, you get to see it here and the folder or directory called public. This is the default schema for Postgres. When you open this directory or schema, you can see two tables, departments and employees. If you can see those, it means that you could successfully create the data that we're going to use in this course for now. Alright, let's move to the next section. Some students who are using Windows 32-bit are having problems with SQL Electron since it only supports 64-bit. In this video, I'm going to show you how can you download and install an alternative SQL client called dbeaver, which supports 32-bit Windows. From Google, I'm going to type dbeaver, and it's the first link. You can directly go to dbeaver by dbeaver.io. From here, I'm going to go to Download. I'm going to choose the Community Edition since it's the free version, and I'm going to choose Windows 32-bit gonna download it and wait for it until it's being done. And from here, I'm gonna use English. You can use any language that you feel comfortable with. You agree. Choose which computer, choose mine. We'll ask again for the language for some reason, and we're gonna go to agree again. Here what you need to do is you need to choose the dbeaver community version and along with the GRE. The GRE is used by the SQL client dbeaver since it's built on Java. Keep those checked. And here you can specify where to install it. Here, if you need any shortcut, and you can say you don't need any shortcut if you don't want to, you can install and wait for it to be done. Your machine may take longer time since my machine is powerful. Not bragging, of course, just like to make sure that if it's slower, it's okay. And you can create a desktop shortcut if you want to. After downloading and installing dbeaver on our machine, I'm going to open it. So the first time you open dbeaver, it may ask you to download a sample dataset or a sample database for dbeaver, so it's free, so you can play around with it using SQLite. We don't care about that for now. What we care about is connecting to Postgres. So from here, on the far left, you can see new connection. Click on it and you'll see the databases that dbeaver supports. So from here, what we want to do is PostgreSQL. Not the old one, but the new one. Can go next. And here you can see the default values for the configuration for connecting to PostgreSQL on your machine. If you didn't change anything, so you should see that the host will be localhost, the port will be 5432, the database will be Postgres, and the user will be Postgres as well. So if you didn't do any changes while installing PostgreSQL on your machine, those configurations should be sufficient. Now you can provide the password. And if it's all good, you can test the connection. Since I tried dbeaver before, when you test the connection the first time, it will ask you to download a number of libraries for GRE that is necessary for dbeaver to run. So instead of this pop-up, you can see a window which will show you the libraries and it will ask you to download those. You can just click on download and all is good. Now my connection is success. I'm gonna say finish. So after that, what you're gonna need to do is you need to download the dataset that is attached in your video here or in the previous video. So after you download it, you need to open it from dbeaver. So you say open file. So based where did you download it on your machine, you need to open that file. Here's my file here. Here's the script that you need to run in order to have the dataset that we need to work on this course. I'm going to select everything. You can do it manually, or what you can do is press click, Ctrl, and A. After that, you can click on the execute button here, or you can press Ctrl Enter to run this. It should be all good. To make sure that everything is fine, you can go here into the connection. You can choose Postgres. You can go to schemas, public, tables, and you should see two tables, departments and employees. If you want to run or open a new file for you to work on, you can say new, and you can select only a file here. You click next, and then here you need to choose general as a folder, or you can create a folder if you want. And next you can name it. For example, I will name it test or exercise 1 or lesson 1, whatever you like. And most importantly, you need to call it .sql in the end, so the dbeaver can recognize it as a SQL file, so you need to run queries. If not, it will show you like a blank file, and yeah, it won't show you the needed execution buttons to run your queries. I'm gonna click finish, and here's a new page. The old page is still there, so the cool thing that you can open as many tabs as you want, so you can work on several pages or several files, and each file can have separate exercises. So I'm gonna show you how can you check if the data is good. So select star from employees. I'm gonna run this using either this or Control Enter, and you can see the data from here. Here's the grid, and here's the data that we have. You can go around and you can see the data. Well, dbeaver gives more features than SQL Electron. SQL Electron is quite light comparing to this, but yeah, on the other hand, dbeaver is a bit more complicated for starters. Anyway, you will take ahead of this. Just take your time, and you can see it's quite simple. It's not that difficult. As long as you reach this level and everything's fine, congrats, you can work with us now. You only need to write your scripts from here. You can execute it using this button, and yeah, you're good to go. Thank you very much for watching. Okay, so now we're going to start learning SQL. First thing I'm going to do here is I'm closing this tab. We're going to start fresh, and I'm going to maximize the window so we can see more. We're going to start together with learning SQL by learning the first statement we need to know. The first statement is called select. What select does, it gets the data that we need from any table that we want, or any query that we require. So select is the main statement in SQL. That we're going to do here is I'm going to show you how to use the select statement in order to get the data that we need from any table. Let's say employees. First, from the editor, I'm going to type select. It is where PostgreSQL can know that get me all the data that I need from the employees table. After select, we're going to show here what columns that we need from this table. Since we have no idea of employees, I'm going to use the star, which is Shift plus 8. Select star means that get me all the columns from a particular table or view or any data source that I am reading from. We get to define what table we're going to read from. So we say after that, from. Then, the name of the table that we need to read from. Now we have two tables, departments and employees is more fun for us, so we will start with that. I'm going to use employees, and I'm gonna type it. That's it. Here I'm telling PostgreSQL to get me all the data from employees table, with all the columns from this table. Let's see the results by clicking execute. Here you go. What you see here is all the data in employees table. Please take note that this data is randomly generated. It's not real data. This is the setup we're going to use in this course, so we have the freedom to do whatever we want with it. So as you can see from the employees table, what we have here are multiple columns from IDs, first names, last names, addresses, states, zip codes, and phones, and other data that we can use later. A table consists of columns like the ID, the first name and last name. It consists of records or rows. Each row, we call it a record because It holds data for an entity. An entity can be anything, like an employee, a customer, a product, a vehicle, or anything that we can define to be an entity or an object to be stored in the database. So for each column and each row, we have a value. Like here, we have first name, like Ili or Joanna, which are employees. Those values of what we need most. When we need save, or when we query from our database. So we can see that we could select from the table. Alright, since that seems a bit big for us, if we can filter it, or let's say for now, we need to select only certain columns. Like, what I need to see here is the first name, last name, and phone of the employees. So instead of selecting star, here we can name the columns that we need to show and separate each column name by a comma. What you're going to do here is you type first underscore name, comma, last name, comma, phone. So here I selected 3 columns, first name, last name, and phone. When I execute this query, what I can see here is only those 3 columns that I defined in this query. First name, last name, and phone. This is cleaner. In case I want to see only the names of those employees and their phone numbers, this is the way you can do that. If you need to call them or connect them or share the information with the HR. It can be anything. Note that SQL is case insensitive, by the way, Means like, whatever character that it's being typed here, capital or small, it's the same and it doesn't matter. So don't worry about that if you type SQL queries. So I'm gonna show you how to type select in all caps and from in all caps, and you see that it returns the same results. For now, we can see the data that we need, or at least we can see the data that we want to work on. Have fun with that and see what data we have for now. We get to move on and talk more about how can we filter our data more and see only the particular rows that we want to report.
What is a database? A database is a collection of information set and organized so it can be easily accessed, updated, and managed. A relational database or a tabular database is a set of data organized into tables. You can think of tables as spreadsheets, but it's far more complex in design and can hold millions of rows. In order to access the data in relational databases, we use a language called SQL or Structured Query Language, which we will learn in this course. Using SQL language, we can access our data, we can update it, we can run various queries and get all the data that we need from the database. Databases can be used for various catalogs, such as sales, inventories, employee profiles, students' grades, and much more. Any data that you can store structurally, you can use databases. Relational databases are usually managed by a manager system or an engine, which controls database users' access and what can and cannot be accessed by those users, and groups as well as managing data reads and writes. Hence the term Relational Database Management System or RDMS. Okay, before going into filtering our data using the select statement, we get to know something called data types. In SQL, we have 3 main data types. We have numbers, dates, and strings. Numbers such as salaries, commission rates, or prices are called numbers, and they are stored as numbers in the database. We have dates such as hire dates, which is the database calendar. We have strings. We call the words, the sentences, or any set of alphabet and special characters strings. Strings can be the first and last names, can be emails and job titles. They can also be phone numbers. Phone numbers are not numbers, by the way. They are considered characters because we type them in a way of a symbol pattern or format, like using dashes or spaces between the numbers so they can be recognizable and easy to read. When we want to filter the data out in our database, we need to make sure and take care of the data types that we are going to filter on. Sometimes there is a misconception between numbers, dates, and strings that they're not being used correctly. When some users filter the data in the database, they use unoptimized ways to filter the data. Or they have some problems how to filter the data and get the results that they need just because they didn't take a good look at the data they have in the table. So here are the data types SQL provides. We are going to take a look at how to filter based on those data types. Okay, your boss wants some data. Let's say your boss comes to you and asks you to get the data that he or she needs from the database. For example, they may ask who are the employees with the base salary more than or equal to $5,000. Maybe they want to fire them, or for tax purposes, or whatever. Anyway, next, they want to know who are the employees with the base salary between $1,000 and $2,000. Next and last, they need the employees with the salary brackets of $1,600, $2,700, or $4,200. We're going to see together how can we get the data for your boss. Let's go. Let's start with getting the employees with their base salary more than $5,000. Starting from the last select statement that we wrote earlier, we're going to see who are the employees who have such big salary. What we are going to do here is, after typing select, then the name of the columns which we need to show and from which table we need to read from, which is employees, what we're going to do next is we need to filter the data. Means that we need all the employees with base salaries greater or equal to $5,000. In order to do that, what we're going to do here is we're going to type after the select statement where. After selecting from the table, we want to filter the data. So we're going to type where so we can define what are the filters or conditions that should be applied to filter the records of employees table. After where, we're going to set which column that we want to filter on. If you can see the data here, you will see that the column that is holding the salary or the base salary of those employees is called base_salary. So from here, after we're going to type base_salary, and take note that you should be careful about the column names. It's case insensitive, but doesn't mean you have to drop the underscore, for example, and it should be the same as what is it in the table. Okay, so after we type the column name, what we need to do is, okay, give me the base salary, which is greater than 5,000. So we want to filter those records. And to show the records with the base salary is greater than or equal to 5,000. So I'm gonna type the greater than sign here to say that give me all the data that the employees of base salary greater than 5,000, and I'm typing 5,000. So this query will get us the first name, last name, and phone from the employees where the base salary is greater than 5,000. Let's see what it gets here. I'm gonna execute it now. Here you go. You can see the employees with the salary or the base salaries of greater than 5,000. Cool. There you go. We could answer the first question. But if you can remember, your boss said that they want the base salaries of greater than or equal to $5,000. So we want to also get the employees with base salaries of exactly $5,000. And so how can we do that here? So in SQL, there is a sign called greater than or equal to. So here I'm gonna type the greater than sign, and after that I'm gonna type the equals type. So here it says give me all the records from employees where the base salary is greater than or equal to $5,000. So in this case we covered or included the base salaries of 5,000. You can see that the number of rows have been different. It used to be 77 and now it's 84. So after I executed the query, we can see there is a difference. So we can look for salaries of 5,000. But since here we can't see exactly how much, and yeah, I should have added base underscore salary before. So I've added base underscore salary into the select statement in order to show the column and to make sure that the query returned the right data. And as you can see, all the base salaries here are greater than or equal to 5,000. As you can see, we have Gayla, which her base salary is exactly $5,000. So if I came back here and I removed the equal sign and I executed the query again, and you take a look, you can't find Gayla anymore, since her salary is exactly 5,000 and the query says we want greater than 5,000. So all the salaries here, if you take a look, it starts from $5,100 or $5,100. So it means that you can't find any salaries of 5,000 or below. Okay, so we answered this request now, and here we get the data, and here we used where, so we can filter based on the base salary. We use the sign, which we'll use to filter the data, either greater or less than, or smaller, let's say, from the value that we're doing so. And I'm gonna show you, if I used less than or smaller than 5,000, you'll see that all the base salaries now shown is exactly below 5,000. You can take a look. Okay, if you used less than or equal to now, and I run this query again, you can check here if now we included the salaries of 5,000 again. So you may find Gayla again. I'm trying to find her actually. Okay, someone called France has a salary of 5,000. Okay, well, I can't find her. Okay, you can take your time to look it up for me. Anyway, so this is the data that we need, and here's how we can filter our data from any table. Okay, so what if we want all the employees where the big salary doesn't equal $5,000? Okay, so we have a sign in that in SQL. Actually, in maths, if you can remember, what we usually do to represent the net equal sign is that the equal sign with a dash on it. Meanwhile, here we don't have this on our keyboard. So SQL helps us do that by using the less than, greater than signs. Yeah, I know it's a weird sign, but this means that give me all the employees with the base salary doesn't equal 5,000. I'm going to execute this, and I'm going to show you that those are the employees with the base salary is not equal to 5,000. And you can take a look, and you couldn't find Gayla or France anymore here, since their salaries or base salaries is 5,000. And if you want to make sure, you can see that the number of rows here is 386. Meanwhile, if I can run the select statement from all employees without a filter, you can see that the number of rows will be more in this case. And after executing this, you'll see that the number of rows now is 393, which means that we have we have less records when we run the filter for not equal to 5,000. Okay, great. So let's move on to the next lecture. Going into the next request. Who are the employees with the base salary between $1,000 and $2,000? As we did before, we could answer the first request. Now we're going to the second one. Let's see how can we do it together. Going back to SQL Electron, now we're going to filter based on the range that we need, which is between 1,000 and 2,000. To filter based on a range in SQL, what we use is, let's say, a term or a keyword called between. What I'm going to do now is I'm going to use the between keyword after where, which because we need to filter based on a range, which is $1,000 to $2,000. And sure enough, we need to use the column, which is base underscore salary. This is the column that we're going to filter on, as we mentioned before. Now we're going to say that, okay, we need the values between 1,000 and 2,000. And as I'm speaking now, it's the exact same actually in SQL, as simple as that. So I'm going to type between 1,000 and 2,000. I'm going to execute this, and checking the data, you can see that the data that returned from this query is all base salaries of between 1,000 and 2,000, including the values 1,000 and 2,000 as well. As simple as that. We may not ask you to put a semicolon at the end, but I usually do that at the end of each query, because what you can do is in the same document you can write more than one query and you can separate them by a semicolon, and you can run all the queries at a time, but you can make sure that they don't collide with each other. What I can do also to make the query cleaner is I can break the one query into multiple lines. So as you can see here, it's much easier to read. Here I can understand that, okay, select the first name, last name, phone, and base salary from employees where the base salary is between 1,000 and 2,000. The last request from your boss is, who are the employees with their salary brackets of $1,600, $2,700, or $4,200. This is simple actually, and with a simple trick we can filter based on those values. So let's see how. Okay, so we need to filter based on three values: 1,600, 2,700, and 4,200. If you can look here, we see that we can't use any signs or any other arithmetic sign greater than or less than. They won't work in this case because here we're looking for an exact value. Even the equal sign doesn't work because it will return exactly one value in this case. So if I say base underscore salary is equal to 1,600, I will get the employees with the base salary 1,600, but I won't get the rest of values. And if I use between 1,600 and 4,200, it will get me all the base salaries of between this range. So this won't help either. So what we're going to use here is a new keyword called in. In databases, we can have what we call sets. A set is like a group of values which are different from each other, or we can simply say they are unique. And there is no two values in a set that is similar to each other, or they're equal to each other in this case. So as the same what we have here, we have 1,600, 2,700, and 4,200, which are all unique values or different values from each other. So in SQL, in order to get that, we're going to use a set. So we select the data from employees where the base salary is one of those values in this set. The keyword we're going to use here is in. and I will show you how. This one, I'm going to delete those since I can't keep them here, but instead I'm going to use them here. And since we can filter based on base salary, what I'm going to say is I need all the data from employees with the base salary is in this set. I'll open the parentheses and I'm going to add those values. I'm going to type 1600, comma, 2700, comma, and 4200. I'm going to remove those because they will cause me some problems if I want to execute the query. So what I said here is give me all the employees whose base salary is either 1600, 2700, or 4200. So if I can execute this query and I will take a look at the base salaries here, you will see exactly those three values, 1600, 2700, and 4200. And you won't find any record with value or a salary other than that. Your boss comes again and they want to know who are the employees hired before 2005 and who are the employees hired between 2008 and 2010, as well as the employees who were hired on exactly 22nd of August 2010. How can we answer all those? Let's start one by one and let's see how can we get the employees who were hired before 2005. Back to SQL Electron, we're going to start fresh and let's select from employees table for now. Here you need to know which column that gives us the dates where each employee was hired. If you can take a look, you can find that hire underscore date is the column that we need. We're going to use that and we're going to filter based on hire date. How can we filter based on the dates here? I'm going to say here that typing where, so since we want to filter, hire underscore date, the first question was to get all the employees hired before 2005. Let's use the less sign and 2005 like this. And let's see what would happen if I execute this query. Oops, okay, we have a problem here. It says that dates and integers or numbers doesn't work in the filter condition in where clause, and since we're using the less sign, and the less sign is comparing between a date and an integer in this case. Numbers which are like 2005 are called integers in SQL. What we need to define here is we need to express 2005 as a date instead. So we need to express it as a full date, which is the year, month, and day all together. So if I want to come here and say that, alright, I need all the employees before 2005, what I mean is I need all the employees hired before exactly the 1st of January of 2005. How can we type this? First, for dates, we start with single quotes. So when you use dates, you need to use them between single quotes, so SQL can know those are dates. Next, you're going to say that we need all the employees before 1st of January of 2005. How can we say that? And how can we type it actually in SQL is we start with the year 2005 and then we type a dash so we can separate between years, months, and days. So since the January is the first month in the year, so its number is number 1. So I'm gonna type 1, it means that it's January. Then another dash and last the day, which is the 1st of January. So I will type 1 as well. So here I have the full date. So what we're saying here is give me all the employees whose hire date is before the 1st of January of 2005. Let's execute this and see the results. As you can see, it runs perfectly now, and we can see all the employees whose hire date is before 2005. We go down and we check the data, and as you can see, all the employees are hired before 2005. You can't find any employee hired after this date. Okay, so here's how we can deal with dates. And actually, sure, you can use the greater than sign if you want to look for employees hired after the 1st of January 2005, the same as we did with numbers. I will execute this again, and you will take a look at the hire date now, and you will see that all of them hired after the 1st of January 2005. If you want to include the 1st of January within your results, you can do the same with numbers in the previous lecture, and you can add greater than or equal to. So here's how you can include 1st of January as well. And actually, you can find data here that for any employee to be hired on 1st of January, because 1st of January will be New Year's Eve and it will be a public holiday, so it doesn't work actually. Anyway, what you can do also is you can exclude a date. So let's say that you want the employees who were not hired in 1st of January 2005. So you can use the not equal sign. Alright, so we answered the first question and we're going to the next one. Who are the employees hired between 2008 and 2010? Here, the same way we filter with numbers, we will do the same with dates, and we want a range. So we're going to use between. This will help us filter based on a range. If you go here, using the hire date as the column to filter on, and I'm going to type between, and I want to say that give me all the employees that are between 2008 and 2010, which means give me all the employees hired between the 1st of January 2008 until the 31st of December 2010, because we want to cover the 3 whole years, which are 2008, 2009, and 2010. We start with 2008 and January the 1st until, so we can add and, starting with the year 2010, and then December, which is 12, and finally the day, which is 31. Here we covered the whole year of 2010. Executing this query, we'll take a look at the data. Cool. So you will see that the hire date is between 2008 and 2010. I have a bunch of, okay. I'm looking for people hired in 2009. Here you go. Here I can't find one. Okay, so you see that we can sort the data in the future lectures. Here, as you can see, the data is a bit like randomly ordered, and what we can do in SQL, we can sort or order the data based on a certain field or column. You may ask, okay, why 31st of December? Because if you go and say, or type, give me between 2008, and 2010 with the 1st of January of 2010, and you run this query, you'll see that all the employees hired in 2010 are missing. Because what we did is we only covered the first day of the year 2010. Meanwhile, the year has 365 days. So that's why we had to cover until the last day of 2010, which is the 31st of December. You don't know how many people mistake this and they wrongly use filtering with dates. So be careful about this and keep this in mind when you filter dates. The last request from your boss is, who are the employees hired on 22nd of August 2010? I think this one will be quite easy for us. Okay, who is the employee or employees hired in 22nd of August 2010?
I'm going to delete all this first, and we keep filtering on the higher date, and I'm going to add the equal sign. And then single quotes. And here, since we're gonna filter on an exact day, we use the equal sign. I'm gonna type 2010, then August, which is 8, and then the day 22. Here we're saying select all the employees whose hire date is on the 22nd of August 2010. After I execute this, you will see that we only have one employee who was hired on that day. Now we want to answer those questions. We want the employee with the last name Alice, employees living in Florida, and employees with the phone number shown here on the screen. In SQL, it's quite simple to get such data, so let's find out. Starting fresh, we're going to check who is the employee with the last name Alice. So I'm going here and type select star, means to show all the columns from the table employees, where here I want to filter by the last name. So I'm going to type last underscore name. To look for strings in SQL, we do the same as we did for dates. We need to use single quotes. Here I'm going to say I need the last name, which is equal to, and open single quotes and then type Alice. I put a string of characters between single quotes because I will show you if I didn't use those quotes. I will execute the query to show you what happens, and you will see that SQL returned an error with the column Alice doesn't exist because it thought that Alice is a column. Let me fix this. I will add the single quotes again and I will execute the query. Here we go. We can see the employee. Her name is Jovita Alice. Please make sure that it's with SQL for strings, they are case sensitive. That means it depends how the string was typed, whether it was all capital or small letters. You use strings as they are in the database or the table you're doing. Here I fixed the O letter again to make it capital letter, run the query again, and you can see we could see the employee again. So now next what we want to do is we want to check the employees from Florida state. So since as you can see from the column we have state, which represents the state of the employee. So we're gonna filter on state is equal to FL, which means Florida. And we can see here now all the employees from Florida state. Sure enough, if I use the small letters here, you think that what results will I get is, sure, I will find no results, since Florida or all the states are represented with 2 capital letters. Next, we're going to look for the phone number provided for us. So since I can't remember the phone number, I'm gonna copy it from the notepad here and I'm gonna paste it. Since you can take a look and you see that we have the column called phone, which represents the phone numbers of the employees, we need to filter using the column phone. So I'm gonna type phone is equal to, and between a single quotes, since phone is a string, I'm gonna paste the phone number. Let's execute this query and we will see that this employee has this phone number. Now for more complicated questions.
But if you want to know who are the employees who live in the states with the second letter of A, or employees' names of 4 letters which start with A and end with E. What we want to know also is the employees whose job titles start with the word data, or the employees' phone numbers that end with 566, or even the employee's address that has the word Washington. Let's find out how can we query such more complicated questions. Okay, we will start with 2 questions. First, we need to know who are the employees whose state's second letter is A. In order to know that, first what we need to look for here is the state as the column that holds all employee states. Then, as you can see here, we can't use the equal sign because it will take the exact string that we will provide. What we need to know here is what employees with the states of second letter is A. So we can use the equal sign. What we need to do instead is we can use something called like. Or let's say that we need the employees whose states names is like a certain pattern or format. So we're going to use what they call patterns or wildcards in SQL. So I'm gonna type here, we want all the states with the second letter A, regardless what will be the first character. So I'm going to type like and then single quotes, as we usually do with strings. Okay, we will look for the second character, which is A, but how can we represent the first character in this case? In case we say that it doesn't matter about the first character, what we need is the second one. So to do that, we use underscore. So SQL will understand that whatever is the first character of the string, I need the second character to be a capital A letter. So it will get me all the states that end with the A letter. Let's see when I execute this. Great, so if you take a look at the states, you'll see that the second letter of each state is the letter A. From California to Washington to Virginia. For fun, let's type, for example, the second letter to be O. And let me execute this. You'll see that we have Colorado. Alright, so what if we want the first letter to be V? So I'm gonna type V and an underscore, and I'm gonna execute this. You'll see that it will be Virginia in this case. Okay, next, we want to see all the employees with the first name starts with A, and the last letter is E. So they will have 4 letters in this case. How can we do that? As you see here that each underscore sign represents 1 slot or 1 letter in a string. So for a word of 4 letters, we're going to say we can use the underscore sign as many times as we want to fill the needed slots of the string. So for all the names that we want, the first names actually, we will look for the first name. So I'm gonna type first underscore name. I keep like because I'm using a pattern here. Okay, what we want to do is the first letter to be capital A. And then what we want to do is we want the last character or the 4th character to be a small letter E. Okay, so about the second and third character, we fill them with underscore. What we mean here is that whatever the second and third characters are, I want all the first names with the first character or the first letter as A, capital A, and the 4th character to be small e. And when I run this, you will see that we only have the name Amy here, with the first letter of A and the last letter of E. Now we want to look up the employees with the job titles start with data.
the employee with phone number ends with 566, and the addresses that have the word Washington. As you can see here, this one is more complicated since we don't know how many characters that we have. With states and with the name that we looked up earlier in the first two questions, we know exactly how many characters or letters do we have. But here, I don't know exactly for job titles or phone numbers or the addresses. Maybe for phone numbers, it may be a bit easier, but what about addresses with, dynamic length, maybe 20 or even 50 or 100 characters. So how can we use that? Let's find out. Coming back, first we need to look up the job titles which start with the word data. As you can see here, we need to look up first which column that has the job title, which is job underscore title. I'm going to use that and look up for titles of data. I'm going to say job underscore title, and I'm going to use like. Since here I can't use equal sign because I'm not exactly looking for data as a word, but the job titles that has the word data, starting with data. What I'm going to use here is the single quotes as usual, and I'm going to use the word data. From here, how can we say that, okay, look up for all the job titles which start with data? Let's see if I use underscore, for example, and run this. Well, I couldn't find anything since, okay, we don't have a job title with only 5 characters which start with data. Maybe I can, okay, add as many underscore as I want, and yeah, I could find something like data entry, because we have here 6 characters which I couldn't locate this, but this one is not efficient enough, it's not practical. So what can we use is another wildcard which is much more efficient. It's the percent sign. The percent sign here, what it does is it tells you that look as many characters as you can find. So the underscore looks for only one character, while the percent sign looks for as many characters, from 0 to infinity. So here, what I say is, look for all job titles which start with data, regardless of how many characters you have after that. Let's see now what this will get us. And sure, it gives us much more data than the previous query that get us using the underscore sign. Let's see the job titles, and all start with data. You have data analyst, engineer, architect, insights, etc. We have database administrator. It doesn't start exactly with data, but database. This one was located successfully because we used the wildcard underscore, or sorry, percent sign. What if, okay, I want to only find the word with is exactly data and a space? As simple as putting a space here, it will locate all the job titles which start with the word data and not, for example, database or data lake or any other word which starts with data, for example. Now let's look for the phone number which ends with 566. So from here, I'm going to delete all this and use phone. Like, single quotes, and I want all the phones which ends with 566. So to say that, okay, I want the phones that end or ends with 566, I'm going to use the wildcard percent. So it knows that, okay, regardless how many characters do we have before, we're going to look for 566 at the end. Let's run this, and here we go. As you can see, we have 2 phone numbers and to our end with 566. Next, if we want to look for the addresses which has or have the word Washington, how can we do that? As simple as that. Let me show you. We're gonna look for the address. We're gonna use like, since equals doesn't work here. Single quotes as usual, and here we're gonna look for Washington. So for here, I'm telling it that, okay, find all the addresses with the word Washington. So from here, what we're gonna use is the wildcard for sure, because I don't know how many characters before and how many characters after that. So we put the wildcard here, and we put another wildcard here as well. Let's try out. And as you can see, you can find all the addresses with the word Washington in it. What about if we can use this? Let's see this trick. I want all the addresses with Washington and ends with the number 9, for example, as you can see here. How does this work? So I'm gonna add here 9. What it means is look for all the addresses which have the word Washington and ends with 9. As you can see, give me only one result, which is we have Washington with the number 9 in it. I'm gonna delete this and let's see more examples. I want, for example, everyone that Washington and have the letter streets, regardless if it's the end or in the middle. How can we do that? Is we say st here, and we can add this wildcard as well, which means look for everything that has the word Washington first, then street st later on. If we run this, you can see that it gave me two results. Both had Washington Street. So regardless street, it came in the end here, but it gave me as a result because street is the end. So when you use a wildcard, even at the end of the string, it accepts it because it depends that, okay, I gave you the result which either ends or contains street. So as you can see in this example, wildcard can be so expandable. So it can check for everything from 0 to infinity. While if I use underscore, for example here, sure, this one won't return anything, but let's try. So even if like st was the end of the street, in case we use underscore, it should be at least one character. If I use another underscore, it says that, okay, find everything that has streets and 2 characters. Won't I find anything either? If I use 3, here you go, it find this one. Because here I'm telling it, okay, I want exactly 3 characters. While the percent sign gives me that, okay, find between 0 to infinity of characters. So here you go. We can see 2 results. Have fun and try it yourself, and if you're done, let's move to the other section. Okay, we did the complicated questions. Now we have this final question. We need all the employees who live in both California and New Jersey. So as we saw that, okay, we get a single state for each one, but what about if we need more than one state? Let's find out. Coming back here, if you remember, when we look up for multiple values, what we used is the keyword in. Here it runs the exact same. So if I'm looking for employees who live in either California or New Jersey, I'm gonna say here where state in either one of those. So we're gonna use state in, open those brackets, and single quotes. I'm gonna say we need California or New Jersey. So in this case, it will get me all the employees who are either stated in California or New Jersey. Here we go. We have employees from both New Jersey and California. As simple as that. Now the question, how can we escape caps? What if we don't know how exactly the names have been stored in this table and we want to look them up without caring about how the capital letters or small letters have been typed in the name or the address? If you come back here and look for all the employees where their address have the word Washington like this, we'll see no results. While if you use the W as capital letter, we can find them. Okay, how can we escape that? We don't want to know that exactly how it's being done, how it's being written, how it's being typed, and we can't escape those caps. The solution in SQL language is using I-like. I-like means insensitive like. It will look for all the patterns that is in here, regardless if they're caps, capital letters, or small letters. Let's find out. Here you go. We could find the same results regardless if Washington has a capital letter or a small letter. If for fun, I'm gonna do it like this, and still the same results. So if we want to escape the case sensitivity, can use I-like instead. For names as well, if you look for Amy or Ahmad in the first name, here you go, we found it. Regardless if it's a capital or small letter. And as you can see, we can use like and I-like the same as equals. While equals is case sensitive, so this one won't return Ahmad. If I use I-like without any wildcards whatsoever, oops, sorry, it says there's a problem here. If I run it again, here you go. Just make sure that when you run anything on SQL Electron, don't select everything, because it will see that you want to run only this script and cause some issues. So just make sure about that. Here you go, and all good. So always remember, when you want to escape case sensitive characters, you use I-like instead of like. It's the exact same of like, but the only difference is that it escapes the capital small characters issues. Hope you had fun, and we saw together how can we use filters for strings, numbers, and dates in order to get the data that we need. Later on, we're gonna see how can we do more complex filtering. Like for example, if you want everything with the base salary above $3,000 and they live in New Jersey, how can we do that? Let's see together in the next section. Now to a more complex query. Let's say we want all the employees who are in New Jersey with base salary above $3,500. As you can see here, we have more than one filter to work on. First, it's the state, which is New Jersey, and then we have the base salary. What about this question? We want all the employees hired before 2015 with base salary of $1,600 and commission rate less than or equal to 35%. In this question, we have three filters. First, it's the hire date. Second, the base salary. And third, the conversion rate. Last question is we want the addresses of all customer care representatives who are seated in Kansas with the zip code 67410. Here also we have three filters. First, we need to check all the customer care representatives by their job titles, which is the first filter. Then we have the Kansas, which is the second filter, which is the state. And last is the zip code. Let's see how we can solve those. Let's start with getting all the employees who are in New Jersey with salaries above $3,500. So if we start fresh and we will type select start from employees, where our first filter is the state. So we're gonna say that the state is equal to New Jersey, which here will be NJ. So if you run this alone, we can see that we get all the employees from New Jersey. Okay, great. So what about if you want all the employees who are New Jersey and they have the salary which is above $3,500? To do that, we can add a new filter or a new condition. Adding a new condition, it will be as easy as saying and. So what I'm saying here is that, okay, I want all the employees from New Jersey and their base salary is above $3,500. So after and, I will mention the base salary and above, which is greater than 3,500. Let's see how it works. Here first we have the state, which is New Jersey, and if we check here, we will find the base salary, which all are greater than $3,500. We need the employees who were hired before 2015 with base salary of $1,600 and commission rate less than or equal to 35%. Going back to SQL Electron, first we need the hire dates. So I'll remove those and say we need the hire dates which is before 2015. So we're gonna say it's less than the date, and as we mentioned before, we use single quotes. We can say 2015 January and 1st. So we need all the employees who were hired before the 1st of January 2015. Next, we're gonna check the base salary. So we're gonna say and the base salary equal to $1,600. We have another filter or another condition, which is we need the commission percentage or commission rates to be less or equal than 35%. If you check this column here, may not be all visible. I will copy it and paste it here. It's the commission PCT or percent. Here it shows that usually we have the base salary and we have how much commission or how much increase in their salaries or raise in their salaries they have. This is how usually some companies do when they store their employees' data. They use the base salary and then they increase it based on the commission. So here we want all the commission percentage which is lower or equal to 35%. To do that, we're gonna say and commission percent is less or equal to, as mentioned in the question. So to mention that we need 35% in SQL, what we can do is we can do it like this, but what we can do is we can mention it like this. This one, it means that the commission percentage is 35%. Let's check the data. Let's execute this, and here you go. We have 2 employees who are hired before 2015, as you can see here. One is 2005 and the other one is 2014. They have a base salary of $1,600. Here you go. And their commission rate is less or equal to 35%, which is here it's 6% and the other one is 11%. So here we use 3 conditions or 3 filters to get the data that we need. Let's see the last query. The last query is we want all the addresses of the customer care representatives who are stated in Kansas with this zip code 67410. So how can we get this? First, we need to filter by the job title. So we're gonna say we need everyone from the customer care reps. Second, we want them to be stated in Kansas, which is the state. And finally, it's the zip code. Let's see how can we do this. Alright, I will remove those from the last query and we're gonna start. So in order to filter by job title, we're gonna use job underscore title. It should be equal to customer care representative. For now, because I don't know exactly how it's gonna be, so instead I'm gonna use I like. So I'm gonna say customer care, and I'm gonna use a wildcard after that, which is the percent sign. So in this case, it will get me all the job titles that start with customer care. Next, the state, which is Kansas. It's K and S. And lastly, we need the zip code. The zip code is 67410. Let's try that. Oops, there's a problem. What it mentions here is that I'm using the zip code as a number, which is wrong. The zip code here in our table is stored as a string of characters. So instead of using it like this, I should put it in single quotes. My bad. So here it says that, okay, the operator doesn't exist, comparing between character varying or strings with an integer. The character varying or the string is a zip code, and this one was a number before I put the single quotes here. Let's try again, and here you go. Let's see this guy first. He's from Kansas. Here's the state. Let's see the job title, and yep, he is a customer care representative. Yeah, I was lucky to get this. And last, about the zip code. Here it is, 67410. So as you can see here, we can do much more complex queries in order to get our data, since we need more information or we need to filter the data as much as possible so we can get the data that we need. Now let's check out another type of queries that we may face. What about if we want all the employees who were hired either before 2011 in May or after the 31st of August 2013? As you can see here, it's different and we can't use between, because in between we have a range. But here we either want all the people who are before May of 2011 or after August of 2013. So between won't help us here. What about if we want the employees who live in Texas or they're working as software engineers? As you can see here, we're using or, like they're either living in Texas or they work as software engineers. So as you can see here, the AND relationship, it doesn't help us in this case. What about if you want the states with employees hired after 2016, working as managers, or their last name starts with T? Here we have three types of filters, but what they want is all three. So here we can't use the AND relationship, because if we filter based on AND, it means that we want people who are hired after 2016, working as managers, and their last name starts with T, which is totally different than what they ask here. They want either hired after 2016, they work as managers, or their last name start with T. How can we solve this? Let's start with the first query. Alright, so as usual, we're gonna select star from employees, where here what we need is we need all the people who were hired before May of 2011. So we're gonna say hire date less than means before 2011 May the 1st. Okay, so next they want the people who are also hired after August of 2013. So we need either or. So in this case we have the or relationship, which can help us in this case. So I'm gonna say I want all the people who were hired either before May of 2011 or after August of 2013. So I should say or hire dates greater than or after in dates 2013 August of 31st. Let's see. And here you go. If you check the hire dates, which I will filter here to make it easier, all the hire dates here are either before May of 2011 or after August of 2013. So if I go down, as you can see, we have 2011 here until April. Sure, the data is not sorted, and we can see later how it can be sorted. And later on, we can see that all the dates after that is since September of 2013. So all the people were hired between June of 2011 and August of 2013 weren't shown here. And here's where OR can be helpful. Next, we will solve the next query. Employees live in Texas or working as software engineers. Here we have two filters, which is the states. and the job title, but they want them both. We want both people living in Texas or the people working as software engineers. It's not an and relationship. There is a difference here. If it's an and, it means like, okay, get me the people who live in Texas and they are software engineers. But this query says that, okay, bring me all the people who are living in Texas or who are working as software engineers. Coming back here, I'm gonna remove all those since we don't need them. And the first filter is states is equal to Texas, which is TX, or we need the people who work as software engineers. So how can we filter based on a job title? So the column name is job underscore title in the table, and here I'm looking for a software engineer. So I'm gonna use I like, since I don't want to care much about the case sensitivity, and software engineer. I'm gonna use star instead so we can see all the columns, and let's execute this. So as I can see here, we get all the people either from Texas or the people who are not from Texas. They should be software engineers. Here we go. So here, as you can see, the OR relationship gets both sides. Like, okay, it get me all the people from Texas, and also add the people who work as software engineer. So the people who aren't working as software engineer, they're from Texas because they're the group which belongs to Texas. And for the people here, which is state is not Texas, they are software engineers, since okay, they came from the group which they work as software engineers. As you mentioned, like if I use I like here, why didn't I use equal to? If you can't see here, I won't get software engineer because simply software engineer, oh, this one is from Texas. Yeah, it get me this one because okay, it's a software engineer, but he's from Texas, so he could get to the group which is Texas. But I can't find any other software engineers since this one doesn't work properly unless I do this, and this will work. That's why I like is cool, because I don't care about the case sensitive aspect, and it worked. Here one is not from Texas, but he's a software engineer. The last query may be like a bit fuzzy or a bit complicated, but we can do it together. We need all the states with either the employees hired after 2016 work as managers, or their last name start with the letter T. Let's see how can we do this one by one. First, the hire date will get us all the people hired after 2016, as we see before. It's easy. Next, we need the people who are working as managers. The column that helps us to get the managers is the job title, and we look for the word manager. And for the people that their last name start with T, we're gonna use the last name column. Let's see together. Okay, going back, I'll remove those as usual. And here I'm looking for only the states. So I'm gonna select only the state here. Next, we have three conditions or three groups of employees. First, the people were hired before 2016. Before or less than 2016. Or the next group. Who are the next group? Who are the people who are working as managers. So, job title, and I'm gonna look for managers, so I'm gonna say I like so I won't care about that. They're case sensitive or not. And here I'm looking for a manager, but I don't know exactly what type of manager. So here I'm going to use a wildcard. I'm going to use the percent sign between the managers, so I'm going to locate all the managers that I have in my table. The last group is the people whose last name start with the letter T. How can we do that? If you remember, we can use also last name with the like, since we're looking for all the words or all the last names with letter T. So since we needed to start at letter T, we don't use a wildcard before because we want the word to start with the letter T. And since last name will be a capital letter, I'm going to use a capital letter here. So no problem with using, we can use like or I like, it's not a problem. I'm going to keep like this to show you how can we use various things. And here I'm going to use the wildcard. So, okay, I want all the words or all the last names which start with the letter T. So we have three groups: people hired before 2016, people work as managers, and people their last name start with T. Let's run this. Here you go. Those are the states that have those three groups. And I think those are like the 50 states. But anyway, we're gonna look up, and to make it like more clear, let's see each one of those. As you can see, the database takes more time since, okay, you need more data. So it will take more time eventually. As more your query can be complicated, it will take more time. And like the more. Alright, so let's see more types of queries that we can face. For example, what if someone asks us that we want all the employees who are not in Texas, New York, or California? Here's different. We want to look for the people or the employees who are not based in those three states. What about if they ask us that, okay, give me all the job titles without any space character? How can we do this? How can we get all the addresses that don't contain the word Maryland, for example? To solve this, let's see how together. Coming back to SQL Electron, let's see how can we get the employees who are not based in those three states: Texas, New Jersey, and California. We're gonna start as usual with select star from the employees where. So before we saw how can we get the people or the employees from, okay, if we have like more than one choice. So if I told you that we want all the people in those three states, what we usually do is, okay, I want people where the states in, and here we use a set. So we have Texas, we have New York, and we have California. Here it will get us the employees who are based in those three states. And sure enough, as you can see, those are the employees living there. Okay, what if I want the employees who are not based in those three states? What can we do? This is as simple as it gets. With one keyword, it can reverse everything and all the results altogether. Simply by using the keyword not in our where clause, it will go upside down and it will get us the employees who are not in Texas, New York, nor California. How can we use not? As we can read it as simple as we say where the state is not in Texas, New York, and California. So here I'm coming and typing where state not in. And sure, you shouldn't use is, because yeah, is not doesn't exist in SQL, at least for this case. So where state not in Texas, New York, California. As you can see, the cool thing about SQL is about the language is quite clear. It explains itself. Let's try this. Here you go. We can see all the states except those three. And to make it easier, I'm going to select only the state column. There we go. You can take a look. You can look for all the records or rows that we have here, but you won't find those three. So, not is quite handy for such queries. What about if we want the job titles without the space character? Means that, okay, we're gonna check the job title, which is not like the space character. How can we interpret this? How can we type that in SQL? I will show you. Coming back to SQL Electron, I'm gonna remove this condition. And here I'm gonna say the job title. So if you want to look for the job titles with no space characters, we're gonna do the reverse for now. I'm gonna show you how we can get the job titles with a space character. To do that, we're gonna use like. Since space characters, they don't have a capital or small letters, it will be the same. Single quotes as usual, and we're gonna use the space here. I want to mention something here that when you use strings with spaces, you need to be extra careful. In SQL, yeah, we can use as many spaces as we want. It's not a problem at all. Like, I can keep as many spaces as I want, and it's a good practice if in case you can clean your code so it can be easier to be read by others. But when you use it in single quotes, so you have to make sure that each space is considered here. You should take into consideration when using spaces inside the single quotes when using strings and comparing between strings. Anyway, so we're gonna use the space, and we're looking for the space character in middle of the job title, since usually, like, if the records are clean, you won't find spaces before and after the job titles. So I'm gonna use a wildcard %sign. So here it will get me all the job titles who have the space character. I'm gonna run this, and as you can see here, it runs. I'm gonna use a star. I'm gonna clean my code. I don't like it to be quite messy. Let's see again. I'll make it even better by using job title here instead of seeing all those columns. And here you go. Here are the job titles with space, at least one space. So as soon as it finds a space, at least one space, it will get it for you. Okay, what we want is the total opposite, which is, okay, I want all the job titles without any space characters. So to do that, we want the reverse, which is, okay, how can we use this? As you remember, we have the not keyword. So to use it, we can go here and we say job title not like. And as you say, like, as we see it in the English language, we're saying where job title not like this pattern or this format of a string that we're looking for, which is this space. Let's run this, and ta-da! We have the job titles without any spaces, with which we can say that, okay, job titles with one word: CIO, treasurer, accountant, receptionist, controller, etc. So not helps us with, okay, getting the reverse of the condition that we have here. The condition with like and the space with the wildcard signs means like, okay, get me all the job titles with the space character. When we use not, it will get me the reverse, the opposite of the condition here. The last query that we have here, we want all the addresses that don't contain the word Maryland. And I think by now, because I think the second query was harder than this, maybe, so this one is quite easier. Let's see together. So here I'm gonna fix it. So we want the addresses which doesn't contain Maryland. So I'm gonna say where address, not like, or I'm gonna use I like since I don't want to go into that capital letter and small letter thing. So I'm gonna use, instead of the space, I'm gonna say Maryland, like that. Let's see the results. Here you go. We can see here that we can't find the word Maryland in any of those addresses. You can take a look as much as you want, and you will find out that, okay, this condition gets us all the addresses which don't contain the word Maryland.
Now I want to run this query, which shows me the first name, last name, state, and base salary for all employees who are in Florida, and the base salary is either $1,800 or $2,200. So here I'm using the and or relationship. So to state that I want everyone from Florida and either the base salary is $1,800 or $2,200. So let's check together what will be the result for this. If I run this and check the results here, you'll see that we have employees from Florida whose salaries are either $2,200 or $1,800. But also, if you notice, we have employees from other states, which we didn't mention here. What we wanted is we want all the employees from Florida only. So why is that? To understand what happens, we need to understand how the and or operators work here. Let's say that in math, we have the plus and the multiply operators, which both work the same way as and or. For example, if I say that I have this, which is 2 plus 3 times 5, what is it equal to? Here, some people may do the mistake that they do the addition first. So they say that it's 2 plus 3, which is 5. Then they do 5 times 5, which is supposed to be 25, which is completely wrong. It doesn't work this way. Actually, in computers, usually in SQL, what happens is the multiplication has a higher priority than the addition. So what happens actually is the multiplication will happen first, then the addition will happen later. So what actually is the result will be 3 times 5 first, which is 15. Then after that, 2 will be added. So the real result in this case will be 17, which is not you're looking for if you want the result to be 25. So how to fix that usually is by using parentheses. So if you put parentheses like that, and so what happens is everything inside the parentheses will be happening first, then the multiplication will happen later. So here what happens is you'll add 2 and 3 together, so it will give you 5, and then 5 times 5 will be 25. So this is how it works in math. The same thing works for and or operators in SQL. Always remember that we can say that the and operator equal to the times and the or is equal to the plus. So what happened here is that the and relationship was applied first. So what SQL understands is that, okay, you want every employee from Florida and their base salary is 1800, or I want everyone with the salary of 2200, which what shows us here. We have everyone with the salary 2200 and we have the 1800 for only from Florida. So how can we fix this? We can fix it by using parentheses. So to fix it, I'm going to use the parentheses like that, and here it will be more clear. I want all the employees from Florida whose salaries are either $1,800 or $2,200. As you can see, it's more readable this way. So always use parentheses when you have multiple and or relationships or operators in your query. So it can be readable even for you and the folks you're gonna work with. So let's run this again, and we will see that now it gives me all the employees only from Florida and with a base salary of either 2200 or 1800. So this is exactly what we wanted here. Now I'm gonna check with you the not relationship. So as we checked before in our previous video, that the not relationship will do the opposite or the negative of the condition that comes after. So for example, if I use not here, where not state equals to Florida, and check the results, so you'll see here that it gives me all the employees with the base salary 1800 or 2200, but with the states, everything except Florida. So what if I use the not operator here? So I'm saying everything from Florida and not base salary equal to this or this. So if I run this, for example, for fun, you'll see that I have everyone from Florida and with base salaries not 1800 or 2200. And you can check the results here that we have none of those two values here. So just to remind you that about the not relationship and how it works. And sure, you can put it everywhere that you want, and it will switch to the condition that comes next. So it's either one condition as we did for states, or the parentheses, which is the group of conditions for the OR operator.
Now we're going to talk about the math operations in SQL. So, as in math, we know the 4 basic operations, which are addition, subtraction, multiplication, and division. So in SQL, we can define those by the plus sign, minus sign, the star sign for multiply, and the slash sign for division. We have a 5th operator here in SQL, which is called the modulo, which we will check together what does it do here in SQL. Let's see together how can we use the math operators in SQL. I'm going to show you now how can we use the math operators in SQL. First thing, I want to show you a trick that it's not necessary to select from a table if you need to do any operations in SQL. So what we can do is we can say select 1, and if I run this query, you'll see that it will return me a dummy value, which is number 1. So we're going to use this to show you some math operations. If I say here 1 plus 1 and execute this simple query, it will give me the result, which is 2, which what we thought of. If I run another query, and I will see that we can say select 5 minus 2. And let's check together what will give us. You can guess, it's 3. As simple as that. What about the multiply? If I say select 5 times 3 and run this query, here you go.
we will see the number 15. 5 times 3 is 15. Quite typical. Now let's come to division. This one may be a bit surprising and a bit tricky, but it's quite easy, don't worry about this. If I say select, and let's say 5 divided by 2. So what we know here is if we use a calculator and do that, it will give us 2.5 as a result, right? Let's run this and see. You can check here that the query returned the value 2. And what about the fraction, which is the half, 2.5, that it should be the complete value? Especially that you know that in usually when you use the computers, it's supposed to return the real values, because any fraction can make a big difference in the results if you do any like big calculations, especially for salaries, for example, as we will see in the next video. The thing is, in SQL, you should make sure that what the numeric type for the sides of the division are. You can see here that we used an integer, which means that a number without a fraction in both sides of the division here. So when we divide integer values together, the result will be an integer. Keep this in mind. So how can we trick this? If I want the floating value, the fractions, the real value, let's say, it should be at least one side of the division operation is a real number or a floating number. How can we do this in SQL? By simply doing this trick, which we can add 2.0, which means that SQL now knows that one side of the division operation is a real number, so it should return a real value as a result. Let me run this and we will see how it goes. As you can see here, now it returned the real value of the division. As we expected, 5 divided by 2 will return 2.5 as a result, which is the more accurate result we expect from math. What if I do the opposite and use 5.0 divided by 2? What will give us? The same result, which is 2.5. The same if both the sides are floating numbers or real numbers. Sorry. It will give us 2.5. So this is how division works in SQL. Keep in mind that always, if you want real values of any division, one side at least of the division operation should be of real number, so you can get the real result of the division. In the last video, we talked about the 4 math operators in SQL, which are plus, minus, multiply, and divide. Now we're going to talk about the 5th math operator in SQL, which is the modulo. So what is the modulo operator in SQL? For people who worked on programming and development on any language, they may have an idea about the modulo operator. But for newcomers, the modulo operator may be new to them. So the modulo operator is simply the remainder of the division for the two sides of the equation. Let me give you a simple example. If we say that select 5 divided by 2, it will give us, sure, the value 2. So for this equation, what is the remainder of the division for 5 divided by 2? As you know, the remainder is what is left from when we divide 5 by 2, which is here, it should be number 1. So if you check it out, the modulo operator here, and I say select 5 modulo 2, which is the percentage sign for the modulo, and I run this, you will see that the remainder or the result of this query will be number 1.
which means this is the remainder of the division of 5 divided by 2. Let's take another example. So we can say 7, or we can say 8 modulo 3. So 8 modulo 3, what will give us? We know that the number that can be divided by 3 is 6. So it will be 6 divided by 3, which is 2. And in case we want to divide 8 by 3, so the result, or the modulo, or the remainder of this equation should be 2. If I run this, as expected, the remainder of dividing 8 by 3 is 2. If we take another example, which is, let's say, 19 modulo 5. Here we know the maximum number, which is dividable by 5 from 1 to 19, is 15 in this case. So if we say 15 divided by 5 will give us 3, which is the result of the equation. And what about the modulo, or the remainder of 19 dividing by 5? It should give us 4, which is what the modulo will give us. And as you can see, when I say 19 modulo 5, it will return me 4, which is the remainder of the division equation. If I say 19 divided by 5. So the idea of the modulo is that it will return me the remainder of the division for the both sides of the equation. And just to know something, that it doesn't matter if one of the sides of the equation is a real number. Here the modulo is always returning the remainder of the integer division between the two sides. So it's unlike, when we do the division here and we say 19 divided by 5 in a floating number, which in return will return me a floating number, which is 3.8, which is the real value of the division. The modulo will return me the integer division between 19 and 5. So this is the idea of the modulo in SQL. And actually it's in any programming language you're gonna use in any computer. So this one can be very useful for some cases.
Finally, it's payday. So what we need to do is we need to pay our employees for the end of this month. What we need to calculate here is the net salary of all the employees of the company. If you can remember from our table employees, what we have is the base salary of each employee in addition to the commission percentage, which we need to calculate. So the math operations that we took in the last videos will help us show what is the net salary for those employees. So what we need to do is we need to write a query which calculates the net salary, which is the base salary plus the commission. If we come back to our table's employees, we see that we have all the details that we need for each employee, from the first name, last name, address, and state. In addition to that, if you go to the right, we can check that we have the base salary and the commission percentage. So how it's being calculated is the commission percentage of each employee is the percentage of the increase on or the raise on their base salaries. So I want to make this query cleaner, so we're gonna take the first name, last name, base salary, and the commission percentage. Now we can see it better and cleaner. So we have the first name, last name, base salary, and commission percentage. So how this is being calculated? How can we get the net salary? Let's take an example. For example, Audrey. So Audrey has a salary of $1,600 as a base salary. And in addition to that,
she has a commission percentage of 61%. This 61% will be calculated from her base salary. So if we want to check together here how much is Audrey's commission, so what we can do is we can multiply 1600 by the commission percentage, which is 0.61. If I run this query alone, you will see that $976 should be added to Audrey's base salary. So the total salary of Audrey should be 600 plus $976. So what we want is to calculate the net salary of Audrey, which is $2,576. So how can we do that for all the employees? Sure, I have over 300 employees here. So it's not, ideal to do this manual calculation, and this is why we use computers and databases in the first place, because they're so powerful that they can do the calculation than us. So I hope you can understand how the calculation should be done, so we can move and write the query. So if we come back, and as we mentioned, we need to calculate the commission percentage of each employee. So based on the math operations that we took and the multiply operator, which is the star, it will help us calculate the commission based on the base salary. So if you check this query here, what it gives us is the first name, last name, and the operation, which is the base salary times the commission percentage, which should return the commission that should be added to the base salary for each employee. If I run this, I'll check it out, and I'll see that I was able to calculate the commission for each employee. And here's Audrey L, and this is her commission as we calculated manually earlier. So cool. We could get the commission for each employee. But now we need to add it to the base salary so we can get the net salary for each employee, and we can pay them today. So what we want to do is we need some changes on this query in order to work. So as we mentioned that we need to add the commission to the base salary. So what I'm going to do is to make it readable and easier for you to understand, first I will add the parentheses for the commission equation, which could calculate the commission for each employee. Now what we want to do is add this commission to the base salary. So what I want to do is I say base salary plus and the commission rate. Hopefully this can be understandable a bit. Maybe it's a bit confusing, especially for people who are not very good in maths, but I hope I could explain it as good as possible. So what you can see here is I could add the commission to the base salary in this case. If I execute this query again, you'll see that we could get the net salary of those employees. And here's Audrey, and here's her net salary. To make sure that you could see it, what we can do is we can show the base salary. As simple as that. So we can do a comparison. And return back to Audrey, you can see that the base salary for Audrey is $1,600, while the net salary after adding the commission is $2,576. So we can see that we could successfully calculate the net salary for each employee here. We saw together how could we calculate the net salary for each employee and show it as a separate column in our query by using the select statement, when we selected the first name, last name, the base salary, and finally the calculation for the net salary for each employee. So this salary has been applied on each record of our query, so it could calculate the net salary for each employee. What we can do as well is we can use the
math operators on the where clause as well. So what we can do is we want to show, for example, all the employees whose commission is over $2,000, for example. So if you go back here and I want to see the commission for those employees, to make sure that it shows me only the ones with the commission over 2,000. So here what I can say is I want all the employees with the commission of over 2,000. So if I run this, you'll see that here in the new column we have all the commission which is over 2,000. So keep in mind that we can use the math operations in the where statements as well. It can be very useful if you want all the details, but you can do the calculations in the where statement instead. So what you can do is you can simply don't show it. I need all the employees regardless, and I don't care about what is their net salary, but what I care is their commission is over 2,000, which will show me here. So it depends. You don't need to show all the results in the select statements. What you can do is you can add your filters. You filter based on a math operation. Sure, this can work on any condition that you want, as long as your math operation is correct and valid for the SQL language. In this video, we're going to talk about string concatenation. What we mean by that is joining two strings together into one. Let's see this example. If I have two words, for example, hello and word, I can join those two strings together into one using concatenation operator. Always keep in mind that when using strings not stored in records, you need to use the single quotes as I did here. So if I go here and I say that I need to join or concatenate those two words into one, this is an operator in SQL that helps us do so, which is pipe. If it's confusing and you can't find it in your keyboard, it should be above your enter key and press shift and backslash. So you need pipe. It's an operator to concatenate or join two strings into one. Let me run this and we will check together the result. And we can see that it returns hello world in one string. What we can do is we can add as many strings as we want. So for example, I can add a third string, which is the exclamation mark, or two exclamation marks. If I run this, I'll see that it could concatenate or join three strings into one. So what's the problem here? If you check hello world, it's stuck into one, which is not usually what we write. When we want to write words, we separate words with a space, so it's much easier to write them, or read them, sorry. So how can we do that here? Here's the trick. Since the concatenation doesn't add a space between the strings for us, what we need to do is we need to add the space ourselves. So what I can do here is I can do this trick, which is between hello and word, I can add a string which is a space. So what I can do is I'll open single quotes, and inside those I can add a space letter. Let's try it now and execute this query, and as you can see, we can see hello world. And the space is between the two words. So this is how we can separate between strings in case what we need to do is we need to join two strings together but without sticking the characters. So we can add spaces or dashes or slashes or any separator that can help us do so. So what we can see now is we have a very great example in our table, employees. If I go back and I can check, we have the first name and last name from employees. If I run this, so this table has all the first names and last names for the employees of the company. What I want to do is I want to create, or I want to show a new column, which is, for example, the full name of those employees. What I want to do is I want to see the full name, and I want them in one column instead of two, as I have here. So what we can do is we can add a third column in our select statement, and we can concatenate or join first name and last name together. So if I do this by pipe and then last name, here I will concatenate or join the first name and last name of the employees. And if you check together, we will see that we have the first name, last name, and the full name, which is now we can see it in the third column here. Sure, we have the same problem that the concatenation doesn't separate the words or the strings from each other. So we can do the trick we did before and we can add the space ourselves. So here I'm gonna add a third string, which is between the first and last name, keep a space in the single quotes, and I'll join it to last name like this. And sure, the concatenation is being done from left to right. So the concatenation will be happening on the first name, then a space, then the last name. It's like any math operation that we have. It's from left to right. Now, if I run this, you can see that the third column represents the full name of our employees. This is how we can use the string concatenation for our advantage. Keep this always in mind. It's a very good trick to do in your queries. Before moving to the next video, just I want to show you something about string concatenation with numbers. So if I come and say this, select hello, and I want to concatenate it with the number 9, which we know that hello is a string and 9 is an integer. So if I try to concatenate or join those together, the result will be a string joining hello and the number 9 into a string. So if you want to concatenate numbers and strings together, those numbers will be in the same shape or the same way that they are being written. So what SQL does is it converts those numbers into strings, then concatenate them with the other strings in the equation. And sure, what we can do is either the number is before or after, it doesn't matter. So if I run this now, we can see that number 10 is in the start of this result of the string, then hello, and then 9. And sure, what I can do is I can separate them with the space. So if I need to separate those, and I have a group of numbers and strings together to be concatenated or joined, so we can see how this can be done. This can be useful if you want to form addresses or form any type of numbers and strings together, and you can create a new column in your select statement and show it off. In the last video, we saw how can we concatenate strings and numbers together. So what we can do is we can form new columns based on multiple columns that we have. For example, here we have the first name and last name, which are string columns. What we can do is we can convert them into one column, which can be called full name. As we did here, you can see that the first name and last name has been joined together to have the full name for each employee. But if you can check it out, the name of the column is a bit quirky. It's not a real name of the column. It depends on what ID are you using or what database are you using, so it can define its own column name in case you're showing a new column in your select statement based on several ones. But what we can do is we can choose our name for the new column that we have created. For example, here we can call this column full name instead of this quirky name here. How can we do this in SQL? It's so simple, and it's called an alias name. We can define aliases as a replacement or alternative name for our columns. So it's not about only creating the new columns based on the select statement, but even the existing columns, you can change their names in case they're not clear, or we want to export it as a report and you want more obvious or more clear names for your boss or for anyone that you're reporting to. So if you want to do an alias for this column and we want to name it full name, it's as simple as that. What we can do is after the column equation, let's say, which will create us the full name column, we will say as, which is a keyword to show that what we want is we want to name this column in a different name or a new name. So after as, I will use double quotes, and it's not single quote. Single quotes is for strings, but double quotes is for column names or for aliases. So here I will say full name. So what I did here is I named this column full name. If I run this query, you'll see that the new name now, what we have, is full name. If you want to make sure that everything is right and to make it more clear, what I can do is I can choose several columns here, and I will show you that, as you see, the first name, last name, and full name. Full name is a newly created column that it's the concatenation of first name and last name separated by a space. And sure, to not mix things up, if I do select star from employees and I run this part, you won't find full name here, because what we did is we didn't create a new column and we didn't add it to the table. Just like the select statement, what will show us in this query that we run. So make sure that if you understand that select statement doesn't do any changes on the existing table. It just shows you what formulas or equations that you're doing on this data, which is a cool part about select statement. So you can keep the raw data in your table, and you can do whatever equations, whatever changes or transformations that you need to do so you can show the data, which is the powerful part of databases in general.
Now, since we learned everything that we need to know, let's make a full report for the payroll department. What they need is the following details from the employees. They want their IDs, names, email addresses, job titles, and their net salary. So let's start together to work on this query and export the report. Getting back to SQL Electron, we will write together the query to generate this report that the payroll department needs. So if we start, we can say select, and what we can do is in SQL it's quite flexible to use as many lines as you need. So what we can do is to make it more clear, we can use each line for a column name.
So first they need the ID. So it's as simple as the ID column in employees. And if I want to show you all the columns that we have, just to make it easier, here you go. Here we can see all the columns needed, and we will start one by one. So first, what we need is the ID, which is quite simple. Next, what they need to do is the full name or the employees' names, which is surely they need the first name and last name. But instead of doing like that, what is better is we can simply create a new column and call it the full name as we did before. So it will be more clear for the payroll department. So I'm gonna do this. I'm gonna concatenate first name and last name, spreading them by a space, so we're having the full name of those employees. And to make it clear, we can add an alias, and I will call this full name. So far we have this, okay, which is like 2 out of 5, I think. So we're almost there, I think. So next, what they need to do is they need the email addresses. If I can show you the email address again for our table, I run this part, and we'll see that we have not the address, by the way, but we have the email address, or it's called email. So you can see here the email was created by using the first letter of the first name and the last name of each employee. But what it misses is the full email. Sometimes they do that because usually companies use their domain name to create any emails. So it's no need to store the domain name for each email, since it should be clear. But for sure, when we want to do the report, we need the full email address here. So what we need to do here is we need to concatenate or join the name of the email, the first part, with the @ and the domain name of the company. Let's say that the company's name is Acme. Okay, so what we can do is mlios@acme.com. As simple as that. To do that, what we can do is I'll say email and concatenate with the domain of the company. So we will join it with @acme.com, which is like, random name, random company name. This way we'll be having the first part of the email and join the domain name of the company, so we'll be having the full email address. And sure, what we want here is we want a cool name for this column. So we will use an alias and we call it email address. So this way it will show a better result. Next, what we need is the job title. So the job title is quite straightforward. So here it is. We have the job title, which is each employee's position in the company. So we will show it as a job title. Easy as that. And finally, we need the net salary of those employees. And if you can remember from the last videos that we did, we have the base salary and the commission percentage. And if you can remember the equation, it's okay. I will just write it here, which is the base salary adding the commission, which, how can we calculate this, is base salary times the commission percentage. And since we need a cool name as well for this, so I'll call it the net salary in an alias. So this is the query that the payroll department needs. It might be complicated at first, but it's quite simple and easy. As long as you have the raw data for our employees, we can do any calculation that we want. What we did here is we had the first name and last name, so we created the full name. We have the first part of the email, so we could create the full email address for each employee, and based on the base salary and the commission percentage, we could get the net salary for each employee. Let's run this and see what it will give us. And as expected, we have now a full report for the employees for the payroll. We have these IDs for each employee. We have their full name, so it can be defined by the email or so. We have their emails, so the payroll can send emails for each employee telling them that their payroll has been transferred to their accounts. Job title, so we can define each employee by their title when we send them an email, for example, or whatever. And finally, the net salary, which is the most important part, so they can know how much they need to transfer for each employee. I hope this is fun. I think we're starting to go to the fun part of SQL. This is our full report, let's say, which is very cool. Have you ever wondered if you can order your records of your report based on a column? Like, I want to be in alphabetic order, or I want to sort them by ID or by the net salary, for example. Luckily, in SQL, we can do that quite simply. In SQL, it supports ordering by any column, either a row column that exists in the table, or a column that is a result of equation or a formula or a transformation that we did, as simple as full name or net salary. To do so, what we can do is, after from statement, we can add the new statement, which is order by, and make sure that order and by are separated from each other. It's not one word, it's two words. So this way we can tell SQL that what we want is, we want this query to order the records based on a column or several ones. Let's see how. For example, let's sort our report by full name in alphabetic order. So what we can say is order by full name. Here we don't need to use the double quotes. It's okay. The same as here, by the way. What we can do is, in case your alias is one word, it's okay to not use the double quotes. But if your report or your query will have two or more words in the alias, you need to use the double quotes in this case. Anyway, so here I said order by full name. If I run this and check the full name, you will see that it's all now sorted in alphabetical order, starting with A, going to B, going down to Z. So this is sorting as simple as that. We can sort by both strings, dates, or numbers. So if I want to add the numbers, which is, for example, the net salary, I want to sort by the net salary. So I can come here and say net salary. If I run this again, I'll see that the net salary has been sorted. And as you can see here, we have this web developer intern who's getting the lowest salary between the employees, since he's an intern. And going up, we can check that the salary is increasing in this column. Going down, and you can see the highest salary in this company. But well, this is exhausting to go all the 400, about approximately 400 columns or records to see who has the highest salary, if you're so curious. So what we can do is, we can either sort ascendingly or descendingly. Means that we can either sort from the smallest to the biggest, or from biggest to smallest, if it's in case for numbers or dates. In case of strings, as you have for the full name, it can be sorted from A to Z or from Z to A. So how can we do that? If you check this slide, you'll see that order by supports two keywords. The first keyword is the ASC, which is the ascending order, which takes the first three characters of ascending word, which is actually the default one. So you really won't use it anyway because it's the default one in SQL. But what we want to do is the descending order, which is the second keyword, DESC, which means the descending order, the first four characters of descending, which will order or sort the query based on the columns that we specified in a descending order, whether it's a number, so it will be from the largest to the smallest, or for a string to be from Z to A. Let's see together. Coming back to the query, you'll see that the net salary is ordered from smallest to biggest here. But I'm so curious to see who has the biggest salary here in our company, and I'm too lazy to go all the way down. So what we can do here is I can come and say order by net salary, and I will add DESC, which means that order net salary in a descending order from the largest to the smallest. Let's run this, and we can see now who has the biggest salary. So he's the head of data, which means like, okay, they're paying much for data these days. So this is the hugest salary or the biggest salary we have in the company. And you go down and you see the net salary is going lower and lower because we ordered the report based on the net salary in a descending order. So what about if we want to sort it by full name, but in a descending order? If I run this, we will see that it's now sorted from Z to A. And as you can see, the full name, the first one is Zona, which is the letter Z, then Yvonne, and going down from Y, W, V, etc. So this is how can you sort your records or your data for a query. In this video, we're gonna talk more about order by. So we saw before that we can order our data in ascending or descending order based on any column that we want, either from the table or from the select statement. So here I'm coming again, and what we want is we want to see all the details of our employees in the customer service department or customer care department. So if you can remember from the previous videos, if you still remember, so what we can do is we want to filter by job title. So what we can say is job title, and I want to say that give me all the employees who are working in the customer department. So we can use I like, since if you can remember, I like is for case insensitive cases. So instead of taking care that customer is a capital letter or smaller letter, we can use I like so we can avoid this problem. Next, we're gonna use single quotes for strings, and I'm gonna use the percentage sign. Just remember that the percentage sign for strings, it's about giving a character or more if you're looking for characters, while in math the percentage sign is for the modulo operation, just to make sure that you differentiate between the two cases. Anyway, so look for everything with the port customer. If I run this, you'll see that it gives me all the employees working in the customer care or customer service. Okay, so what we want is next I want to order this data. So I want to order it on several attributes. So the first thing, I want to order them by job title, and next I want to order them by name. So in this case, I can order first the job titles instead of having a random or a messy report. So I can order them so it can look more better. So in case it will be easier for the one who's using the report to see that all those from the same
same team or the same department for the customer division, let's say. So always remember that the order by comes last in the select query. So when you write the select statement, first comes the select, you select your columns, then the table name in the from, then the filtering using the where clause, and finally comes the order. So I say order by, and then I will say and to order it by job title. If I run this, now it will be ordered by the job title. At first by the customer care manager. Going down, you'll see we have the customer care operator, which is because M is before O, so manager is before operator. Going down, and you will see that it's ordered by alphabetical order. And sure, if I use the descending order, which is this one, it will be the opposite. Checking out, and you see that customer service, which is S. Then if you go down more, you will see that it will be the customer relationship, which is R. So the alphabetical order is from Z to A. Anyway, so first I want to sort it by job title. Next, if you see the report more, you see that, okay, we sorted everything by job title, but you see the full name is a bit, it's a bit messy. So what we can do is we can order by full name next. So in case we have two records with the same job title, we will order the one with the full name in an ascending order. So I can add here, using the comma, I can add full name. And if I put ASC, or I didn't put it, as we mentioned in the last video, the ascending order is the default one. But I will keep it to show you that it will work either way. So now, in this query, I'm ordering first by job title, then by the full name. And as you can see, we have first the customer care manager, then the operator. Okay, so when we have two records with the same job title, you'll see that the full name will be ordered first. So first it will be Ahmad, then Eliza, then Lily, then Mitsu. So as you can see, you have the letter A, AL, then Lily with L, and Mitsu with M. So it will sort first by job title, next by full name. What we can do also is, to make it better, is that maybe instead of full name, we can order by the net salary in a descending order. So what we'll have here is the job title will be ordered first, then the net salary. I have a problem here, which is, okay, net salary doesn't exist because, as you can see here, I had a problem because of the net salary. If you see my query, the net salary here doesn't exist. So it simply didn't know what is the net salary. So I'll fix my query by adding net salary here, so it will work again. The cool thing about order is that it uses the alias. What we can see next is, unfortunately, where clause can't use the order or the alias. Sorry, I'll show you an example about this later on. So anyway, so here I have the net salary, and if I come here, you'll see that now we ordered by job title first, then by the net salary. So you'll see that for the records with the same job title, we're having the net salary, which is the highest first. So for the customer care manager, we have the highest, then to the lowest. Then if the operator will be having the highest and the lowest, and the same thing over and over. Sure, the data is quite random and it doesn't represent any real data, so you can get some wacky salaries, like an operator getting very high salaries for even American standards. Anyway, so this is how you can order, even ascendingly or descendingly. So just, you can specify descending, so it will order this column in the descending order. And if you don't specify anything, or you can just mention ASC, or means the ascending order, it will order it in an ascending order, which is, yeah, this keyword is quite useless and nobody uses it because it's the default one. But yeah, it's there, so you need to know if you need it, or even if you read it one day in some query. Maybe some people like to add it because it will show that, okay, I'm adding this in an ascending order while the next column in the descending order. And sure, you can order as many columns as you want. For example, what I can show is I'm gonna add hiring dates here to show you that we can order by dates as well and timestamps. So what we can do is I will add here the hire dates. So what happens is, from this now, it will order first by the job title, and in case you have the same job title between two records, it will be the hire date. And as you can see, the hire date is working. So first is 2002, then 2005, then 2006. If you can check the operator, it starts with 97, then 98, etc. And in case you have, let's see that, show you that it can order by several columns, I will use the base salary to make it easier for us, because since it's very hard to find two employees with the same net salary. So if I go here and I will check out, I want two employees with the same base salary. So later on you can check that in case if you have, if you have two employees with the same hire dates, in this case if they've been hired together, so it will for next order by the base salary in this case. So I'm gonna show the base salary here just for see if we have anyone with the same base salary. Okay, so if you check it out, now what I'm doing here is, if you check the order by, so it's first by job title, the base salary, and the hire date. What does it mean is, in case if I ordered by job title and they are the same, it will order next by the base salary. And in case we have two employees with the same base salary, so it will order next by the hire date. So let's check together if we can find someone. Okay, so it's very difficult even to find the same base salary here. Oh, here we go. So we can check this one. So we have Letty and Alicia. So for Letty and Alicia, they're working together in the customer care operator team. And what they have is the same base salary, which is 4,200. But what happens is, for Rashida as well. So we have three people with the same job title, which is the customer care operator, and the same base salary, which is 4,200. So as you can see here, we have two columns with the same values. So as we ordered here, we have the job title, we have the base salary, and next one is the hire date. So we'll check out that in case the job title and the base salary has been the same values, equal to each other, the third one will be the hire date, which we can check here between those three. And as you can see, first it was Rashida, which was hired in 2003. Next it was Letty in 2005, and Alicia with 2011. So here's a good example that you can order by several metrics or several columns. So in case the first column was equal to each other, it will order by the second. If the second was equal, it will be ordered by the third, either ascending or descending, depending what did you mention here, etc. So this is how the ordering works. As simple as that. It's quite cool and it's quite easy. And yeah, it's like very simple, but at the same time, it will give you a very good report and a very tidy report based on what you need. Alias names are very cool, as we saw with full name and net salary. Unfortunately, we can't use them with the where statements. Means like we can't filter using
the alias names, which are full name or net salary. Let me show you this example. If I come here and I say, I want to filter based on job title, for example, and I want the net salary to be over $3,000. If I run this, unfortunately, this query will return an error that the column net salary doesn't exist. Although, it's defined here in the select statement, but the where clause only depends on the real column names in your tables. So sadly, we can't use the aliases in our where statements when we do any conditions. Sure, the same for both numbers and for strings. So even for full name, I can't use whatever. So it doesn't work. So what you need to do in case you need to you need to add conditions to an alias name or like for net salary. Sadly, what you need to do is you want to use it as is. So for example here, you want to use the whole thing and you can say and the base salary, the whole equation over 3,000. Yeah, it sucks, I know, but this is how SQL works. So keep this in mind that, okay, some people may go crazy that why doesn't my query work? Because simply SQL doesn't support using alias names in their where statements. When we run a query like this, which is select star from employees, this query will give us all the records in this table. Now it depends on the IDE or the tool that you're using to connect to your database, whether it's Toad, it's SQL Electron, it's MySQL server, everything that can depends on which IDE you're doing. It can limit your number of records you bring in there, because now our data is only like less than 400 records here, but what if you have a table with millions and millions of records? You can imagine that this will consume much RAM even in your machine, and it will crash because it will be much memory allocated to show you all those records. It happens often that, especially now we are in the big data era, which millions of records is now quite the norm when you work on any medium to large project. So what you need to make sure is you don't need to consume much of your data and make your relational database quite, exhausted by bringing you all the data that you need, especially if you have a query that is quite complex, much mathematical calculations, for example, and many columns. This all it has an effect on how much time does your query take. Here our data is quite small, so it's quite fast. It's taking milliseconds, but when you have millions of records, this may take minutes, even sometimes hours if your query is very bad. So what you need to do is there's a way to limit the number of records that you're bringing from the database. This can be very, very cool and very easy. It makes your database administrator quite happy that instead of reaching 100,000 records and consuming the relational database's resources, banning anyone else from using it, you can simply get the first 1,000 or the first 100 records and even the first 10 records in case you want to check the data of any table you don't have an idea about in the first place. So this one is quite simple. So how should it be working is you can simply, when you write your query, at the end of the query, you can limit the number of records to be obtained from your database or from your table. So here I'm gonna, for example, limit it by 10. So here you can give the keyword limit and you can give a number which indicates how many records should be obtained based on the query. So if I run this, you'll see that I only brought 10 rows or 10 records from the table employees in this case, which can be faster. If you can check that 10 records took much faster than, let's say, the whole table. And we're talking about a table of 400 records here. So you can imagine if you have a table with 1,000,000 records, how much time will it take and how much resources you will consume. So always keep in mind to use the limit when you use tables with such big data, let's say. For the limit, it should always be at the end of your statements. So for example, if I have where, and let's say, for example, the base salary is bigger than 3,000, and okay, order by, let's say, the first name. So the limit should be at the end, after order, as you can see. So if I run this, here you go. So it brings me all the employees who are the base salary is over 3,000, and it ordered by first name, as you can see here, and it's only the first 10 records. So this can be very, very useful. For example, okay, I want the top 10 employees with the highest salary. We can do that. Sure, there are other metrics to do this, but this is the easiest way to do so. And I see many analysts, data analysts, and even developers do that. Instead of going to the more complicated. It's not very complicated, but yeah, it's the easiest one to get when you want to get a query the fastest possible. So let's see. Okay, I want the top 10 employees in my company. So what I can say is order by the base salary or the net salary, let's say. To make it easier, it's the base salary for now. We won't go into the whole equation thing. And order in a descending order, so it will bring from the top to the down, and limit by 10. And to make it easier, I just bring the first name, last name, and we will see the base. I want to see the title, so let's see the title. We can't see the states, and finally the base salary, which is we need to know how much. So I will run this, and we'll see that it gives me the base salaries, the top 10 in my company. So we'll see the base salary. The top base salary is $9,500, which is for a CIO. They're paying much for information technology from Oregon. And we'll see the next one will be 8,500. It's the revenue accounting and controls chef. I don't know what is that, but it seems like a big thing. So yeah, like as you can see, the heads of departments and the chief officers, the C-level, are having the highest salaries, which is understandable. So this is how limit can work. It can be by everything. Top 3. There we go. So for example, I want the top 3 from a certain state, where state is equal to New York. So here's something wrong, which is where. And as you can see, this is a good example to show you that if you mix between the order, or sorry, between the order of your query, that order by is before where, it won't work. SQL is not flexible with that actually. So first it should be the where, then the order, then the limit. From this again, I will see the top 3 in New York, the top base salaries. And as you can see, all 3 are from New York. This is the job title for each one, and the base salary. I'll show you that limit can be anywhere. So if I put it, like, for example, before where or before order, as you can see, it will return a problem or an error. So always remember now, since what we took is select from where, order, and limit for now. So we have those 5 statements. It should be by this order. If we want to browse all the states that are stored in our table called employees, so we can simply do this. We can say select state from employees. And when I run this, I will check out and I can find all the states that in this column. The thing is, if you look it out, that we have repetitive values because it simply shows us all the state values for all the 393 records in our table. So it might be a bit annoying. What about if we can filter the values so we can get the unique ones? Luckily, in SQL, we can do that using the keyword distinct. The keyword distinct helps us filter any column or a group of values, let's say, to the unique ones. If I come here and I use the word distinct before the column that I want to filter and get the unique values from, this query now will show me only the unique values of the column state in the table employees. If I run it now and we will check it out, you'll see now that we have only 45 rows comparing to the 393 rows that we have earlier. And if you check the values now, you'll see that we won't have two records, let's say, or two values of the same state. So what we can know here is that our employees are scattered around 45 states. So in this case, distinct is very useful to filter any column that we want to only show the unique values. For example, we can show also for, let's say, zip code. And it shows me all the zip codes stored in employees, but the unique ones. And as you can see, we have 362, which is about the same since we have 393, but it's okay. Shows us the unique zip code values that we are storing in employees table. So this is distinct. Now, if our boss asked us to see all the job titles hired in the company grouped by state, how can we do that? Let's see together. Going back to SQL Electron, what we're asked to do is they want to see all the job titles that are hired in our company in employees table grouped by state, which means that they want to see for each job title that we have, for which state does it belong to. So as simple as that, what we can do is we can show the state and the job title at first. Let's see together. We'll see that here what we're showing is for each state, what is the job title that this employee has been hired in which state in this case. So this is about what do they need in the report that was shown in the slide. However, as we mentioned before, what you may see is the same job title may be occurred several times, the combination of state and job title. If I can show you more, we can order this by state and job title. And if I run this, you'll see that while here it's quite distinct or unique, let's say, but if we go down a bit more, we can see, for example, in California, we have the same job title repeated again and again, which is the accountant, because we have several employees working as accountants in California. When we export this report won't be as clean and it will be a bit confusing for your boss or who reported to and requested this kind of report. So what we can do is we can use distinct in this case. So you may ask, how can we use distinct for multiple columns? In case if I use distinct, then I set a set of columns or defined a set of columns after the word distinct. What it does is it will give me the unique combination of those columns. Let's say that for state and job title, we see that we have several states and each state has several job titles. In this case,
the query will do the cross of all the states with their job titles and the unique values with them. For example, for California, as we saw, we have accountant, which is repeated several times. So when we use distinct with both state and job title, what it has is we will get all the unique states as well as their counterparts of the job titles that we have. So what we have is here, for California, we will be having accountants. It will be all grouped by one value. Then we have the actuary, the administrative assistants, etc. So what will be happening is, for each state, it will cross it or combine it with each job title in a unique value. So what does it mean? That, okay, it will first have a distinct state, then for each state it has its distinct job titles. To see it together, I will add here the word distinct. Now if I run this, we will see it now that we have the state and we have the job title. It may be confusing at first, that some people may ask, oh, but we have several states, like we have Arkansas here repeated several times. Yeah, because we have several job titles. So what it shows here is that for each state, it will show you what is the job title. But this combination, this value here, those two columns are unique. Means like you can find another record with the state Arkansas and the job title accountant if you look it up. And since we ordered here, we can see that we will be having only one record with this value. And you can make sure that we have 345 rows, so it means that we're having like the less than the total number of employees, which was 393. So if I go down and I check the California, we will see now that we have, for California, we have only one record with the combination California accountant. So in this case, what we did is we have now the unique combination of the state and job title. Sure, when you add more columns, it will give you more and more unique values depending on the columns that you have here. So if you have several states, it will be unique to one for each record. And if you have several job titles for one state, it will be unique for one record, each state, and etc. So keep this in mind, that distinct is quite useful to give you unique values for a column or a combination of columns. We're going to talk about null values. What is a null value anyway? A null value is simply a field that has no value. We call it a null value. For example, in some cases, maybe when we set and insert the employee's details into our database, some of those fields are missing, like for example the phone number. So in this case, we can set this field as empty or as null, let's say, to be updated later on. So this can be useful, so we can check what values are missing, so the HR department can follow up with the employees and they can fill it up later. We can see an example here, and we're gonna check our data for the employees table. So what I know that in our data, some phone numbers are missing for some employees. So what I'm gonna do is I'm gonna say where the phone, and here if I want to filter by the null values, I can say equals null. This one doesn't work. It depends on what database you're using. In this case, it will just return no values, which is wrong in our case. In Oracle, it will return an error value, an error that says that you can use the equal sign with null. So what you need to do is always when you use null, you say is null, and always remember this. So when you use null in the where clause, you use phone or the column is null or is not null.
So if I run this, you will see that here we have the phone numbers as null. And again, null is not a value, it's not a string, it's just a no value, a nil. So here, only the UI will show you that we have a value which is null here. So it can help you detect that those columns, those records, it has a null value in the column phone. Sometimes it depends on each IDE you're using or UI. It may be like be a blank, a gray square, a yellow square. It depends what UI are you using. In SQL Electron, it shows you as a gray box with a null value inside it. So anyway, it will help us say that, okay, we have those 4 records and 4 employees with no phone numbers, so we can fix that. And to show you that the phone or the string, the null value is different from an empty string, which many people may fall to this trap, I will show you if we say where phone is equal to an empty string. So I just open and close the single quotes, which means that I'm looking for an empty string. If I run this, you'll see that I have 3 employees with empty strings. This might happen sometimes, depends on how the developer is programmed the platform, so it can store empty values, let's say. Maybe it's like, yeah, something related to development side. It's not related to the end users. Sometimes end users put spaces, for example. It may happen. So there are measures that should be taken when storing data into our databases. So we need to keep it as clean as possible. So anyway, this one can be confusing. This case can happen a lot. So don't think that you won't see it anywhere. Sadly, it's like a frequent use case. So what I want to do here is I want to see all the records with missing phone numbers. So I will say it's either the phone is equal to an empty string, which is a single quote with no values, or the phone is null. So you'll see that actually I have 7 records with no phone number. So in this case, what we can do is we can report the HR department to check with those employees to provide them with the phone number, so we can later on update their records in our database in this case. So what we can do is we can select the ID, the first name and last name for those employees, in addition to, let's say, the job title. So in this case, okay, we can report this to our HR department so they can check the phone numbers and get the phone numbers to be updated later. We're going to talk in this video about case statements. Actually, case statements, maybe it will be the most complicated we saw so far. Not that it's difficult, but it has more code and more typing than usual. So as we saw for if you want to do a comparison or a classification for our values, let's say, for example, if we want to do taxation and we want to say that if the salary is between this range and that range, so call it class A or class B, etc. What we can do is for states, what we have in this database that we're using the abbreviation of the state names, NY for New York, NJ for New Jersey, etc. So what we can do is we can add the full name using the select statement. So what we can do is we can start with the states, since it can be easy, and show you how can you write a case statement. So let's start, and what we can say is select, and we'll say from employees. So here I'm gonna add spaces so it can be easier to read for you and easier to understand how the case statements work. So you start with the case statement with sure, the keyword case. So SQL understand that you want to write a case. So case, for programmers, they can understand case as the if and else and then conditions.
So for newcomers, don't worry about that, you can understand it here. So what we can do here is we can check a value and compare its value to several values. And when the first match comes, it will consider the case column value as the one which is matched with. So let's take this as an example of the state. So what we want to do is we want to compare the value of states to a number of values. So what I'm going to say is case states, which is the column that we have now in employees table. So next, what we want to do is I want to check the state value for a number of states, let's say, and we can replace the state abbreviation with the full name of the state. So how can we do that? When we say for each matching case, we use the keyword when. So we say when and the value, then, okay, consider the new value for this old value. So when we say that, okay, for case states, when the states is equal to FL, then replace it with the word Florida. We can add as many cases as we want. So when NY, then replace it with the word New York. And when, let's say, NJ, then choose New Jersey as a value. You can add as many states as you want. You can add all the 50 states. To make it faster here, I'll add all those three. What we can do is, what if the states doesn't have any of those three values? What you can do is you can add the final states, which means that if all the conditions weren't met, consider this. What we call this one is else. So if all the matches have been false, if state doesn't equal FL, NY, or NJ, else means like take this value, which here we will say other, for instance. So here what we did is we wrote a case statement comparing the value of states to number of values, which are the abbreviation of the states for the United States. We checked FL for Florida, NY for New York, and NJ for New Jersey. And if we we have if you check the earlier videos, we see that we have 46 states in our table. So yeah, for the other 43 states, we're gonna change it to the word other. As simple as that. So in this case, we will consider those values and those matches, and we can close the case statement with the word ends. And this one is quite important. Even I forget sometimes to use this. So always remember that when you use the case statement, you say case, then in our example here, we use the state value, which is we need an equal comparison, and then we can put each match on a when statement or when clause. So it's when the value, then take this value. When the second value, take this value. And you go on, and in case you want to none of those values have been matched to states, you can say else, and you can put the default value in case none of those matches return true. And you close the case statement with end, the keyword end. So to make it easier for you, so what we can do is we can show the state, put a comma, and by the way, the case can be it's a separate column, so you don't get confused. Some people may get confused. Should I put it before select or after select or before from? This one should be inside the column definition of the select statement.
So sure, the case, this one, is a column in the end. So I can add as many columns as I want, and like for example, first name, last name, state, job title. So I can add as many columns as I want. So I can add case among those. And sure, I can add a column after that. So I can put a comma here and I say, okay, for example, the base salary. So you see that I put my case statements inside or wrapped inside the case, the select statement here, which is, it will work fine. So let's run this and see. And as you can see here, which is our case statements, it replaced each state with the value that it will be represented with. So if you check, most of those will be other, because we have 46 states and we only defined for 3 states, but you can check for the ones that we matched with, which is FL for Florida, New Jersey with NJ, and if you check a bit more, you can find New York with NY. So yeah, what you can do is, as a homework, you can add all the 50 states, and yeah, you can have fun with that if you want. I won't do that, I'm too lazy. So this is how we can use the case statement in this case. It can be very useful if you want to replace any values or you want to add any values. This can be very useful as an if statement. This has been added to SQL, so you can do conditions. And this one is quite simple, but there are more complicated examples. We can check how can we compare with integers later on. The final thing that I need to check here is, okay, how can you add an alias? As you can see here, it will give me a random alias here. So what can do is, after the end keyword, just make sure here where you can add the alias. And sure, because the case statement here is one of the columns that the select statement is showing, you can add an alias. So what we can say here is the state's name, as for example. And if I run this, you will see that I created an alias for the case statement here, and I called it the state name. Sure, this one you can write it all in one line if you like, but you can imagine how tedious and how hard it is to read it. So yeah, you can imagine that, for example, if I do that and someone else that needs to read this query from you, if they need to check proof it or something, yeah, it will be a nightmare to someone to read this. So always remember that what you can do is you can break your query into several columns, several lines, so it will be much easier to read in this case.
If we return back to this slide, I did some changes and I added the income tax. So now the net salary will be the base salary plus commission minus the income tax. Let's see how the case statement will help us do the new calculation of the net salary for our employees. Back to SQL Electron and our case statement. We saw that what we can do is we can see the tax that we calculated earlier. And if I run this query again to make it cleaner, here we have the base salary and we have the income tax. What we want to do is we need to calculate the commission again, and we need to subtract the income tax from it so we can see the net salary. How can we do this? This can be a bit ugly, or let's say can be a bit complicated, but bear with me and hopefully you can understand. So I'm gonna add the commission percentage here to see it. Right, and here it is. So if you can remember how we calculated the net salary, which is the base salary, and the commission, I'm gonna show you how. So I'm gonna add a new line, and if you can remember, what we did is it's the base salary times the commission percentage. So in this case, we could calculate here the commission that we needed to be added to the base salary. So what we do is we can simply do this, and
I'm gonna add the base salary here. So in this case, what I did is I added the commission to the base salary. So now what we have is the net salary, as we did earlier in the last videos. Now what we want to do is we need to subtract the income tax here from the net salary. So how can we do this? This one can be very simple, but maybe this the SQL query can be a bit more complicated. As simple as that, since the case statement will return a single value, which is the tax formula that we did earlier, so you can consider the case statement as a whole one variable. So in this case, what we can do is we can simply do that. Instead of using case statements as a column, what we can do is it will be inside our equation like that. So if I change the here and I say the net salary, so as you can read this, you would see that this one is a whole new equation, which is the base salary plus the commission minus the income tax. So this one will calculate the commission. Here is the base salary, and this case statement will calculate the net salary. So what I did is I simply created an equation or a formula that it will calculate the whole net salary for each employee. So to break it for you, I'm gonna do this, or to make it easier to read, so it will be like that. So here's my equation, and you can see that this column is going to be the base salary plus the commission minus the income tax, which it will be returned by the case statement. So if you read it one by one and slowly, you can understand it eventually. So what I did is I put it piece by piece, the base salary, the commission, then the income tax here. And this is one of the complicated queries that you might find later when you use SQL. So this can be a very good use case. So your heart will beat fast now, but eventually you get over it. So I found this, and let's see, hope it works, and it did. So what we have now is we have the first name and last name for each employee here. We have the base salary, we have the commission for them, and finally we have the net salary. So the net salary will be the base salary plus the commission minus the income tax. Sure, what you can do is you can break this and you can see each column separately, and let me show you. So here I'm gonna add the base salary, then I'm gonna add the commission, and as commission, and next I'm gonna add the income tax. So I'm gonna copy all the case statement here. So I'm gonna call it the income tax, and finally this huge formula here, it will be the net salary. As you can see here, for each column I'm separating them by commas, so the SQL query can understand. And if this one is confusing, I'm gonna break it into multiple lines so you can see it better. So we have the first name, last name, base salary, the commission alone. Here's the base salary again, so I'm gonna remove those, not needed. Okay, and here's the first name. I'm gonna clean this up. First name, last name, base salary, the commission here, and the case statement, which is the income tax alone. And I had to repeat it again. So the problem with SQL, and this is one of the weaknesses, that you can't use the same column again. In this case statement, for example, I can't say income tax here, and I can show you later on. This is one of the weaknesses of SQL, unfortunately, and this is why sometimes you need to repeat your script again and again. So if I make it like that,
So here it is. I'm gonna show the first name, last name, and maybe the first name, last name, we can make them as full name, as we learned earlier. So as the full name. So yeah, now like we're like exercising on everything we learned so far. So here's the base salary, which is the commission. Here's the math operations. Here's we're using between, and we're using the comparison equations. So the case statements, here's the whole equation for the income tax or net salary, and from the employees. So hopefully it should be better. And here we go. So this is the full thing. I'm gonna make this longer to see it. Here's it's like 21 lines long. This is the biggest SQL query that we have to write. So you should be proud of yourself. But first, let's run this. I'm gonna run it. Let me make this smaller and we'll see the results. So if you see here, we have the full name. We check the base salary. We can check the commission, which is this value. We can check this is the income tax. So this is the net salary, which is the base salary plus the commission minus the income tax. So you see how SQL can help us do the calculations quite fast. Like you can sure do that in Excel maybe or LibreOffice, but you can imagine if you have millions of columns, or sorry, millions of records, which Excel will crash if you try to use that. So databases are quite powerful for such financial calculations. This is why databases are quite powerful and cool, and you should learn SQL in the first place, because it will help you and help the team do such calculations for big data. So you can see that we could calculate the net salary for our employees, showing the details for, the finance team or the payroll team, so they can send it as a report to their emails. And yeah, if you like, I can show you the email as well. As an exercise, you can add the email address here as we saw before. So yep, you can play around with this query, and you can add as many details as you want. So here's your full big report. Congrats. Okay, finally we're gonna start a new section, which is functions. So what is a function? Actually, functions give us much capabilities in SQL, since we can do things that we can't do before. For example, if you want the sum amount of the net salaries for all the employees, or we can get the count of employees for certain states, or we want to know the maximum or minimum base salaries per state, for example, or per zip code for other statistics. What we can do also is we can trim or clean up our data. Like for example, if we have names with no caps, we can fix that. We can trim any spaces if it's before or after the addresses, let's say, or job titles. Such things we can do in normal SQL or what we did so far, so functions can help us do so. There are many functions, they're predefined in SQL, and they're gonna help us. So what is a function anyway? A function, we can say, it's like a black box that there are a set of instructions inside. So when we give it an input, which can be one argument or more, it will give us exactly one output. So we can check for examples. This may be scary that for people who don't like maths, but it's quite simple. So for example, in the first box, we have a function which takes x as an argument and returns x times 2. So if we give it x equals 3, so the output will be 6. For the second function below, we can see it takes two arguments, x and y. So what it returns is x times y. So if we send x as 4 and y as 3, the output will be 12. So what the type of functions that we have in SQL? We have two types of functions in SQL. We have single row functions and multiple row functions. As an example for single row functions, they are the functions that they are executed per row or per record. For example, if we have two records on the left, which are for Sam and David, if you apply the function called upper, what it does is it makes all the characters in caps. So as you can see, from the left to right, you'll see that the names Sam and David are now all caps. This is a sample of a single row function. What about a multiple row function? A multiple row function is that it takes all the records field as an input, and as an output it will give us exactly one value, which depends on what function did we use. For example, there's a multiple row function called sum, which gives us the sum amounts or the sum of all the values for a certain field. Let's say we have the field called amount here, which has those values as we see 500, 300, 200, and 700. If we apply sum on the field amount, we will see that it will return the value 700. So this is the difference between single row and multiple row functions. In the next video, we're gonna start with multiple row functions because they're quite more useful, let's say, or yeah, it's very useful to know them first since you can do many stuff with those. And we will go eventually with single row functions and learn what functions and what type of functions do we have in SQL. In the last video, we talked about what is a function and what type of functions do we have in SQL, which are two types, multiple row functions and single row functions. We're going to start with multiple row functions in SQL, and we're going to play with 5 functions which are the main multiple row functions in SQL. They are sum, the average, count, min, and max. Please note that those are the most important functions for multiple row functions, and the first 3 you're gonna use them a lot. So make sure you can understand how do they work. They're quite simple and quite easy and quite fun. Getting back to SQL Electron, what we're going to do is we're gonna apply the multiple row functions we saw in the last slide into our table employees, and we're gonna start with the function sum. What sum does is it gets us all the total value for a certain field, and sum only takes numeric fields, means that only fields with numbers. So since it does the addition on all the records for this field. So since for our table we have base salary as a numeric value here, so we're gonna say that what we want is we want the total base salary for all the employees in this table. How can we use the sum function? What we come here is we come to the select statement and we say sum, we define what function do we need to use, and then we need to pass the arguments of this function so it can give us the output, which is the total amount or the total base salary in this case. So we will open parentheses, and inside the parentheses we need to say what argument or what arguments, depends on the function and how many arguments does it take, we need to pass or we need to calculate. So sum takes only one argument, which is the field that it will give us the total value of, or the total value of all the records. So we're gonna pass the base salary, which is the field that we're interested to see the total amount of. So this is it. What we did is we defined what function to use, we open parentheses, and we pass the argument or the arguments that this function needs to return the output that we're looking for. So this function or this query will return the total base salary for all employees. Let's run this and we'll see what it gives us. As you can see here, this is the total amount of all the base salaries for the employees in this table, which is $1,362,800. So this is sum, as simple as that. Let's make it more fun. And let's say that, okay, I want the sum total, the base salary for a certain, let's say, state. So I can say where state is equal to Washington. If I run this, you will see that the total base salary for the employees stated in Washington is $22,500. We can use New York, for example, or California, since I think we have many employees from there, and you can see it's more than what we have in Washington, which is 189,000. So here's how the sum function works. Now to the next function, which is called the average. What average does is it gives us the average numeric value for certain values in a certain field. For example, we want to see the average base salary for all employees in our table. So what we can do is the same way we did with sum. We say select, and then we call the function average, which is named AVG in SQL as an abbreviation or short for average. So next, we open parentheses so we can send the argument that, or the field that we need its average, which is in our case the base salary. From which table? From employees. As simple as that. We run this. So we run the query and we see that it returns the average of all the base salaries that we have for all the employees in the company, which is by average $3,400 or about $3,500. And you can see it's a real number or a float number, since it should return the real average and not only an approximation, since this function is used a lot for calculation and for averages if we want to calculate the mean or the median in later functions. So here it's quite simple. As you can see, the same way we used with sum, we use with average. And what we can do also is we can filter by states, and we can say we want everything from New Jersey, for example. We want to see the basic salary or the average base salary in New Jersey. And here you go, you can see that the average salary is a bit higher than the average salary for all the company. As you can see, this can be very useful for comparison if you want to look for the average salaries and the median ones among the states. We'll see later how can we see for all the states and not only for a certain state using the group by. So we're gonna focus now on checking all the functions first, and the cool part is I can use both average and sum at the same time, so we can do something like that. So here what I'm doing now is I'll be having two columns, one for the average and the second one is for the sum. So we will see both values at the same time, so I don't need to run two queries in this case. So as you can see here, I got the sum base salary for New Jersey, which is 145,200, and I have the average as well. And the cool part, I can, for example, I can get in, like, okay, I want everything that is in, let's say, Florida, and we can say Colorado. And we run this and we can have the sum for both states and we can check it out, the average, how it is. What we can do also is you can fix the alias for those, like instead of having this auto-generated alias, we can do as, and we can call it, you can use this or no, average base salary or base sal. And here you can say as sum base salary. If I run this, you see that we could fix the alias for the result of our query, select query here. So yeah, it's nice. Now we're gonna talk about the count function. What the count function does is it counts the occurrences of values in a certain field. So this one can be quite simple and quite straightforward. What I'm gonna do here is I'm gonna use the count, and let's see that, okay, we want to count how many values in a certain field or a certain column. Let's say, for example, count first name. So what we're gonna do here is we're gonna count how many first names do we have in Colorado and Florida, which means that we're counting how many employees actually do we have in those states. If I run this, you will see that we have 31 employees in the states of Colorado and Florida. If I remove this and we'll check it out, how many do we have? We have 393. And you can check it out that it's true if you go and simply say select star from employees. You'll see that we have 393. So the count is very useful if you want to count how many fields or how many records we have, for example. So for a certain table, any table like orders, students, books, so you can simply count how many books do we have, how many employees, how many students, how many cars. So yeah, the count is like to count the occurrences of how many items do we have in a certain field. You can count the whole table, which, okay, for our example, the same way we counted for first name, you can simply make it more general by saying select count and then use star. So in this case, what you can do is you can count how many records are in a certain table. So this one is quite used a lot because simply people want to know how many records we have in a certain table. So even if you have a huge table and you want to know how many records we have, you use count star, and you'll see it will return us the total number of records. And maybe someone will say that, okay, I can't depend on this. Actually, this one is supported by the UI or the IDE, SQL Electron. But the thing is, you may not see this when you use the command line, the terminal, or any other UI, because sometimes it can be too expensive if the table is huge. So let's take another example. What you can do is you need to remember that for count, it doesn't count the null values. If you can remember from the last video, we talked about null values. So when we have a null value, you can't use count, or let's say count won't count it, to say the least. If you can remember, let's see, we have select phone where phone is null. So we checked together and we found we have 4 records with the phone number as null. So if I come here and I say count phone, as you can see, it will return 0. Although, like we saw earlier, that we had 4 fields or 4 records, right? The thing is, count doesn't count the null values. Remember this. So the same, for example, if you can say, and I'll show you that if I say the select counts for phone in the whole table, you'll see that it's missing. We saw that we have 393, and what I can show you is I can do this count star. So we can compare between the total values. Oh, okay, sorry. Here in SQL Electron, in case you're using more than count, you need to use an alias. It's a weakness, or it's a bug in SQL Electron, or let's say a limitation. Anyway, so count all, and I'm gonna call this count as count phone. So here, the count phone, we have 389 phones, but the total employees are 393, which means that we have 4 phones with the values of null.
and you make sure that there's a difference, since it could count the empty ones, which means if I say select phone, where phone is an empty string, you'll see that we have three records with empty phone, which is like can be a space, or here in our case just empty. And we mentioned before that it can be due to development, or any case that okay it entered an empty string, which is different than null. Anyway, this is count, and this is how it works. So what we can do is a count. Here, if you turn back and we want to see the total, so we can say now we need the count star, or which counts all the employees. We have the sum for the base salary, and what we have is also the average for the base salary. So here, so far we took three functions, and we can see that we have 393 employees with a sum base salary of 1,362,000 and an average of 33,467 or $68 approximately. So we see three functions so far. Those three are the most important. Keep them in mind. The other two are less used. They're important as well, which are min and max. But keep in mind that those functions are quite useful. So keep them in your mind, and they can be very useful in your career or in your studies. Finally, we're going to talk about the min and max functions in SQL. What they do is simply give us the minimum and maximum values respectively for a certain field that we pass as an argument. So here we're going to see it together in a one query, and we're going to see, let's see the minimum base salary from our table employees, and it's 700, which if you check you can see it's for an intern or someone. So same thing, we can see the max. So what we can do is we want the max base salary from employees as well. So you'll see the difference, that what we have is we have the min salary, which is 700, and the max base salary, which is 9,500. What you can do is you can use it as a formula or equation. So what we can do is we can say give me the minimum minus the maximum of the base salaries, and we can see the difference. And here you go. We can see that the difference between the minimum and maximum base salaries for our employees is $8,800 US. What we can do also is, sure, we can filter person states. So we can get states in, let's see, New York and New Jersey. And as you can see, the minimum salary in both New Jersey and New York is $1,000, while the max is $8,500. So this is how the minimum and maximum works in SQL. Sure, you can add the average, the sum, and finally the count and count star. And we can move this so you can see that we have all the values that those five functions give. So the minimum of the base salary, the maximum, the average, the sum, and the count. You can play around however you want, because the next video will be quite more exciting than this one. We will see how can we group the values based on a certain function, or how can we group based on a field, or what we call a dimension. So what we call the min, max, or the average can be a metric, and what we can call states, zip codes as dimensions. So for example, I want to see the average salaries per state. So that's what this one can be quite
useful to check for each state, or by job title, or we can by two dimensions, which are both the state and the job title. So in this case, we can see for each state and job title how much is the minimum and maximum. So if we want to do an analysis of the base salaries for our companies, so in case they want to do a layoff or they want to do a raise or a promotion, those things are taken into consideration.
Before moving on, we're going to talk about how can we count the unique values for a certain column. If you can remember, we could show the unique values for a certain field or column using distinct. So what we did is we say select distinct states from employees. And here we could show the distinct or unique state values for the field states. So what we can do is we can count those as well using the count function. Here, how can we do it? Instead of saying select distinct states, and what we can do is we can call the function count, and inside the parentheses we can say distinct, and then we can say which column or field we want to count. And for this example, we're going to use state for now, and from the table employees. And here we can count how many states do we have totally in our table called employees, which is 45 states. Another example is if you want, for example, count how many job titles do we have in the company. What we can do is we can count the distinct values of job title. And here we go. We can see that the company has 133 job titles. What you can do also is, for example, I want to see how many job titles do we have in California. So I can say something like that. And I can find 38 job titles in California. So in our case here, like for example, what we can do is we can look for the the positions that are hired already, so we can check how many empty or vacant job positions, so we can fill them some way. This is one of the examples we can do. What we can do is we also count the zip code. So in this case, here we can see that in California we have 45 different zip codes, which means like our employees live in 45 different zip codes in California. We can count everything if we can just miss this, and we will see that about 362 employees 362 zip codes are the total zip codes our employees live in. And if you can check it out, how many employees do we have? You can see, so here I will use an alias. Okay, so you see that we have 393 employees living in 362 different zip codes. You can understand that, okay, we have 2 employees or more living in the same zip code. For example, if you want to like organize a bus transportation or something, this can be useful somehow. I don't know. So you can play a lot around and you can see who are the employees living in the same zip code. We will see we have a good example, and later on we can check who are the employees who are living in the same zip code. Stay tuned. Let's answer this question. How many employees do we have per state? So let's see how can we do this in SQL. If only we had a function that can count how many employees do we have, which we do, which is the function count. Let's see how can we do that. Getting back to SQL Electron, let's see how can we count how many employees do we have per state. We saw earlier that what we can do is we can count how many employees in the whole table. and it's 393. But what do they want is, how many employees do we have in each state? They want to know how many do we have in New York, New Jersey, California, Colorado, Florida, etc. So what will you do in this case? You think it's a good idea to do this every time? Sure, you can do that, but since we have about 45 states stored in employees table, that will take like 45 queries, and that will take you at least 45 minutes to do that, while you can do that in 1 minute. Let's see how. What we can do is, since we want the state here, so we need to show the state. And then what we can do is we can use count and star. So do you think that using count state will work? What we want is we want to count how many employees, means how many records do we have per state. So here what we're doing is we're gonna count how many employees do we have per state, and from our table, which is employees, and this will give an error. The error says that the column state, which is in employees table, must appear in a group by clause. What does this mean anyway? When we mentioned that we want to see how many employees do we have, or the count of employees that we have in the table per state, we need to say to SQL that the counting is based on state, which we can say it's the dimension of the query. What do we mean by dimension is that, okay, the metrics that we want to take here, which is the count, on what dimension that we want this count to be based on. When we have no dimension, usually it's the total number of records. But here what we want is, we want to say that give me the count of records per state. So to mention that, for SQL to know that it should be per state, we need to define that in a new clause called group by. So here what I need to do is I'm going to remove the semicolon, and after from employees I'm going to say group by. Here I can define what dimensions that I want to apply the count on. Here, for example, we want the state. So group by state. So in this case, the SQL query will count how many employees or how many records do we have in the table employees per state. Let's run this and see what happens. And here's the magic. You see here that the SQL query counted how many records, which represents the employees we have in the table, per state. And if you check here, you'll see that for California we have 55 employees, which I think they are the most that we have. You can check later if you want. And you can check for Texas, for example, we have 26. For Ohio we have 17. For New York we have 34, and etc. So this is the magic of grouping and using group by with the multiple row functions, that we can do calculations or analysis in a very easy way. And here what we could do is we know how many employees do we have per state. Sure, you don't need to put state here, but as you can see, yep, we can see what state is this. Like the data is, we can't understand it. It's useless because I don't know for each count, like 55, for which state does it belong to. So it's not about what do you put in the select statement, but what do you put in the group by clause. So since we defined that the group by clause will be based on state, it will do the grouping for us and count for us based on the state. But sure, for us, we need to see it in the end. So what we need to do is we need to say states and along with the multiple row function that we're using here, which is the count. So run it again and we can see per state how many employees do we have. Change of plans. Since now they saw how can we easily do finding the count of employees per state, now what they want is we want to know how many employees do we have per state and job title. Means that, okay, we want to count how many employees do we have in per state, and depends on the job title, we need to count how many employees we have holding the same job title on each state. For example, how many customer care representative do we have in California? Or how many software engineers do we have in Washington? Getting back to our query from the last video, here we will see how can we add the job title as another dimension in our query in order to see the count of employees per state and job title as mentioned in the last slide. So here we can simply add the column job title to the group by and sure to the select statement so we can see it as well. And let's see, here we can see that now we can see how many employees do we have per state per job title, and it might be mostly 1 or 2, so we can look it up here, which can be a bit difficult. So let's do some sorting and ordering so our script can be easier to read, or our results can be easier to read. Let's say, for example, I want to see what are the most job titles being hired in our company. So what we can do is, first, what I'm doing here is I'm gonna give it an alias name for the count star, since it will be easier this way. And then what I want to do is I want to order the data descendingly by the count all. So here what I can do is order by, and I'm using count all, and in order to sort the data in a descending order, if you can remember, we use DESC, which is for descending. And let's see. As you can see here, the most hired job title in the company is an accountant based in California. And we saw that by the first record that we have here. If you can do something like that, limit 1. And we can see only one record in this case, which can be more clear. So running this back, and we can see how many employees do we have per job title per state. If you want to make it cleaner, we can order not only by count all, but what we can do is we can order by job title and then by state. So first what is going to happen is it will order by the counts in a descending order, and if 2 records have the same count, it will order by job title, and if it happens that they have the same job title, it will be the state. If I run this again, we will see that now we can see a little better and cleaner data. Ordered first by counting in a descending order, then job title in alphabet order, and the state in alphabet order as well. But sure, as you can see, since the counting is first, so you can, the state alone can, it appears like it's random, but actually it's ordered. So you can see, like, for example, if you can go down, you'll see here that when we have software engineers from different states, this one is from California and this one is from Florida. So the one from California came first, since the state is applied for a sorting. So California came before Florida. Yep, this one is like we already talked about in order by video, but yeah, I'd like to remind you about it and how can we use order for such queries. So that's it for counts. And we can see how can we use sum, min, max, average on grouping as well. Now for more fun, let's answer this request. We want a full report of our job titles in the company per state. What they want to know is the count of employees per job title in each state, the average and minimum base salary, the sum amount of their net salary, and the maximum commission rate. Since now we already know all the functions needed for this and how can we group based on a certain dimension, so we can easily do this. Let's go. Getting back to SQL Electron, let's see how can we write such query. It might be complicated at first, but it's quite fun and you'll see it how easy it becomes. So we'll start as usual for a select statement, and since we have a query with it will be a bit complicated, I prefer writing each line or each record in a separate line. So first what they want is the job title, then they want the state, and those are the dimensions that they want to group by. Next, what they want is, first thing that they want is the count of employees per job title per state. So we can use count star to count how many employees do we have. And I'm getting an alias to make it clean, and I will name it count imp from count employees. Next, what they wanted is the average and the minimum base salaries. So here we know the two functions, and we're gonna use AVG, which is the average, for the base salary, and I will call it average base salary as an alias. Then we can take the minimum, which is the min function, and we want the minimum base salary as min base salary. Next, they want the total amount of the net salary. Be aware that they want the net salary, not the base salary. So we want to make sure that we know how can we do this. So first we need the function which is called sum and parentheses. And let's remember together how can we calculate the net salary based on our table, which is we have the base salary and the commission percentage. If you can remember from the last videos, what we did is the net salary is the base salary plus, and we calculate the commission, which is the base salary times the commission percentage, which is in between 1 and 100%. So here what we did is we did the formula for calculating the net salary and we added the sum function. So this is quite logical and reasonable and it works 100%. What we did here is for each record calculate the net salary and add it to the sum amount. So this one will go to each record for each employee. It will get the base salary, the commission percentage, calculate the net salary, then add it to the total amount. So here I'm gonna call it total net. So this will represent the net salary, and don't forget the comma. And finally what they want is the max for the commission rates for each job title per state as max commission percentage. And here you go. Here we have all the needed fields for our report. So we're gonna read this from our lovely table, employees. And what we need, since we want this report to be based on job title and state, to group by those two columns. So here's the job title and here's the state. So this is pretty much it. This is what we need for now. Let's see what this will give us. Oops. So the commission rate doesn't exist because, okay, here, sorry, it's the commission percentage, my fault. I run it again and voila. Here what we have is, if you take a look, first we have the job title,
for each state. So it will give us information about the count of each job title for each state. For example, here you have a senior software engineer based in New York, and it's a count of 1. Sure, the average and minimum, the total and max is useless for the counting for one employee, so we will get rid of this. But we don't want to go into all that, because since like most of the data is for based on one state and one job title, so the count is always 1. So what can we do to make it better is we can order by the count of employees in a descending order. So in this case we can see more meaningful data. So if you can come here, and we'll see that, okay, for accountants based in California, we have 5 employees. So the data will be more useful in this case. And the average base salary for those is $3,160. The minimum base salary for them is $1,800. So the total net will be for those is 23,000, and this is the max commission percentage, which is 74%. So sometimes, yeah, people may have minimum base salary, but the commission will be high, because some companies, what they do is they keep the base salary, but they raise the commission. So maybe some people, the commission rate can be at 200%, so they can get like several raises or several promotions. So when they enter the company, they have a minimum base salary, but it can be doubled or tripled later. Anyway, this is some HR payroll thing that I can understand well, but yeah, this is what we have in our table anyway. And we can see that we could get the data that the report from our boss needed. So it looks all cool. We used the aliases to make clean and tidy columns, and this is the data that we need. What we can is, in case, like as you can see here, we have the same count, so we can order again by job title and by states. So we're having a more cleaner data, so we can see that we have the assistant store, which is in alphabetic order, and customer care operator. Or what we can do is we can order by the average base salary. So sometimes what they want is, okay, we don't need the job title to be in alphabetic order, but what we want is order it by the average base salary, and there you go. So we'll see here that, okay, for the ones in the same count, which here you can see that the ones with average base salary from small to big is being ordered here in this case. So you can order by any by any field that you want. So depends on what the report is for. You can order it so it can be tidier and can be cleaner, because you before you export it and you send it to your boss. So this is as simple as that. As you can see that, okay, and you will see such report a lot if you're working as a data analyst. So yeah, what we did so far is very good. Like we could, okay, get a full report. It can be very useful. Sure, maybe we need more columns or more or less, and that's it. But yeah, like most of the reports that we're doing, you will use those 5 multiple row functions all the time. So get practice on those, and it's very, very useful. And yeah, have fun. The person who asked for the report came back to us again and asked us if you could please remove the records with no more than 1 employee per state. So since we checked the report and we saw that based on the metrics asked, if a record or job title has only 1 employee, the metrics are not useful, and I expected that. But you think that, okay, they can remove it themselves, but you can't imagine how many lazy people I had to work with, so this request can happen often. Let's get back to our query and try to fix it to show us only the records with more than 1 employee per job title per state. Getting back to SQL Electron and getting back to our SQL query we wrote earlier, which we're so proud of, we want to fix this. So
it can show us only the count of employees more than one. So here where we get the count of employees, so this column, if we can play around, and how can we show only the count which is greater than 1. So the first thing that I'm going to do is we can simply do this, where count imp is greater than 1, right? So if you check it out and make it bigger, what do you think? Will this work? Let's see. Oops, it didn't work. What is the error? Count underscore emp does not exist. If you can remember, since I talked about aliases, aliases are not recognized by the where clause. So you only can use them in the order, but you can't use them on conditions, or even in grouping, by the way. So what you need to do here is, this one doesn't work. So what do we need to do then? Since we're using count underscore emp, why not using the original value of this field, which is the count star? So yeah, it's a good idea. So we can say where count star is greater than 1. Let's see. And yeah, the same problem. We have another different error here, which is the aggregate functions are not allowed. Aggregate functions means the multiple row functions we called earlier, which can be called aggregate functions as well. So yeah, SQL doesn't allow aggregate functions to be in the where clause. So how can we solve this? Luckily, sure, in SQL, there's a solution. And here when we can be introduced to a new class, a keyword called having. Yeah, this is a cool thing. So having, you don't see it much in many queries, but it's quite useful in such cases. For example, if you want to filter by an aggregate function or a multiple row function, as the 5 functions we know so far, what we can do is we can filter using the having clause. So how does it work? Having clause comes after the group by and before the order by. So I'm gonna use the keyword having, and here where we can say count star greater than 1. So what we did earlier is we tried to filter using the where clause, but where clause doesn't allow for multiple row functions or aggregate functions. So instead we're using having for this. Let's see, and voila. Now it's gonna work, and you will see that our report will have only the count of employees greater than 1. That's really cool. And this is the report that we asked for. Let's do some playing ourselves, and what we can do is, for example, we can add a new condition, and let's see, the min base salary is greater than $1,200. See here that we have some records with min base salary of $1,100. So what we can do is, in having, we can use several conditions. And sure, I'm using min base salary, but this is my fault. What I should say is main base salary. Yeah, I fell to the same mistake myself. Anyway, if I run this, you'll see that what we can do now is we filtered for the min base salary above $1,200, and you'll see here that we don't have any records lower than $1,200. So having is a great choice if you want to filter based on the multiple row functions or the aggregate functions. And sure, it works on all the 5 functions we learned so far, which are count, average, sum, min, and max. So having can be very, very useful. And I was surprised how many SQL developers, data analysts, and even students
researchers, even data scientists, don't know much about having. Having is quite powerful and it's very useful, so keep it in mind. So if you look at the select statement structure, so it gets complicated video by video, but yeah, I can assure you we're like about the end of select statements. So what we see here is what we can do is first in the select statement comes the select, sure. We either use star for showing all the columns, or we can define the columns that we need to see. Then from which table that we want to look the data from. Then the where clause, where the conditions, the group of conditions can be added. Next comes the group by, and you can define what are the columns that you want to the query to group upon. And next having, which we took just now in this video, which it comes between group by and order by, with the conditions as we used now later. And next comes the order, and we can say how can we order, by what columns. And finally the limits, which limits how many records do we want to fetch from the query that we're running. So please make sure that this structure is quite strict. You can switch between from and where, or between order by and group by. So this is the structure. Sure, the most important part is select statement, and as you can see, everything else can be optional, except maybe the from, in case you need to use where or group by or any one of those. And sure, when you do any where or group by, the columns should exist in the table in the first place, sure. So anyway, keep the select statement structure. This is the way in mind. Many people do mistakes in their queries. They don't know what's the problem and why does it return an error, because they simply are not aware of the select statement structure. Keep this in mind and you're good to go.